Welcome to the second day of Paris MariaDB Server Fest 2020. Bienvenue à Paris pour le deuxième jour de MariaDB Server Fest. Nochmals willkommen in Paris für den zweiten Tag. Yesterday was an exciting day and we'll have more of the same today. Feel free to share the presentations and your comments on social media, LinkedIn, Twitter, Facebook, or whichever you like. Every talk has its own URL, so you can share your comments on individual presentations. And remember joining the chat on Zulip as described on mariadb.org/zulipfest. We have one topic for each presentation within the stream MariaDB Server Fest presentation, so you can continue chatting when the next presentation has started. So now for today's program. We'll start with Sveta Smirnova, how to migrate from MySQL to MariaDB without tears. So migration is a common denominator of many talks here, and sometimes you migrate from MySQL, sometimes from Oracle, sometimes from other places. This time we focus on experiences related to MySQL. Sveta Smirnova will then continue in today's second presentation, and that's also a green presentation, one concentrating on best practices, modern solutions for modern database load improvements in the latest MariaDB version. So what are the features, what are the best practices based on latest versions of MariaDB Server. Then we'll go for a yellow presentation, meaning a use case, and this is about the financial industry. So Tera Zhou, how to help financial customers use Tencent Cloud MariaDB. So financial customers have very stringent requirements on uptime, high availability, security, ACID isolation, disaster recovery. And how do you actually cater to those? It's a long time since MariaDB was not a candidate or a best practices database for such scenarios. All of those are now featured in MariaDB, so you can do mission critical financial applications, and here are some use cases related to that. Then we have a long block of blue presentations. The first one of those is by the very own Vincenzo Torbaru of MariaDB Foundation. And Vincenzo will be talking about a topic that so far Monty has mostly been presenting. So the creator of MariaDB, Mikael Widenius, his latest complete new feature, if you will, is the S3 storage engine. And now Vincenzo's long-term archival with MariaDB's S3 storage engine will give you a perspective on S3 from somebody by somebody else than Monty himself. The next presenter after that is from MariaDB Corporation, Richard Bensley. He has a couple of war stories on interesting features, interesting functionality that really can help you in certain use cases, in certain scenarios, and even some horror cases that he will share. SQL mode equals ludicrous is a good title for such a presentation. Then the MariaDB Corporation presenters continue, this time Sergei Petrunya, who will have an optimizer trace walkthrough. So again, helping you optimize your own application by understanding how the MariaDB Server optimizer works. And after him, we'll go to Galera. So there's two Galera presentations, both by Seppo Jaakola of Codership Galera. The first one is a general overview, and the second one is an overview of the latest version. So the first one, MariaDB Galera cluster, also for people who are new to Galera cluster, and the second one mostly for those who already use it and looking at the specific features of Galera clustering in MariaDB 10.5 and beyond. The day is concluded by Federico Razzoli, who today will be presenting the Connect storage engine, playing with the Connect storage engine. That's a storage engine that based, if you will, the possibility of using other databases than MariaDB, but with the MariaDB layer on top. So we access the other databases through a storage engine layer, and that's important, for instance, specifically in a migration scenario. So that's day 2 of MariaDB Server Fest in Paris. Let's get going. One more thing, some highlights from yesterday. Those who viewed us yesterday might have noticed that we had a couple of glitches when it comes to connectivity, but we're so happy about the whole concept of having the films already present. So we got a very shaved version of Valery Kravchuk with Monty as his stand-in, and then later on a slightly less shaved version with Vincenzo Ciorvaro. What was also great yesterday was the interactions over Zulip. So I want to remind you, please do so today as well. The discussion can go in both ways. Sometimes the presenter asks questions from the audience, but above all, there's interaction between the people of the audience and with the presenter directly, because the presenter is present on a live chat. When the presentation is done, it still remains live in the live stream. Over the course of this conference, what we're doing is that we're putting just that part of the live stream onto the URL that has been constant already since the very beginning of the conference. Let's take the Supermetrics presentation. Its URL is mariadb.org/fest2020/perfectdb. That one currently contains the live stream, but very soon it will be just the presentation by Dupes and Victor. These URLs are then meant for easy reference when you want to share it after the conference with somebody else, and of course for social media. So we're happy if you share the presentations that you liked using their URLs over LinkedIn, Twitter, your favorite social media. And then, as the final thing in this one more thing part this morning, we are going to name the sea lion, and we will ask your help to do so. And you can submit your names. Stay tuned for the exact rules. We want to know why you suggest a certain name as well. And the winner will be picked. The winner of the choice for the name of the MariaDB Sea Lion will be picked by Maria herself, and the award will also be artwork created by Maria. The following presentation is by Sveta Smirnova, how to migrate from MySQL to MariaDB without tears.
Hello, today we will discuss how to migrate from MySQL to MariaDB. A little bit about myself. I'm MySQL support engineer with more than 10 years experience. Currently I work in Percona, and in Percona we support all MySQL flavors. It's first is Percona software for MySQL, and upstream MySQL Oracle's version, and MariaDB. So I work with customers who use all these products. I am author of book MySQL Troubleshooting. I have a couple of hobby projects on GitHub. I am a frequent speaker on various conferences. And here is our topics. These are topics which we will discuss today. And a little bit about MariaDB. MariaDB started as a fork of MySQL, and then it became independent product with many unique features. And at the same time, since it started as a fork, it started as fully compatible fork with MySQL, its many important improvements are backported from MySQL. It's before it started as a fork, but now improvements get imported, so these are different code base, and you need to understand this when migrate, especially from latest versions of MySQL to latest versions to MariaDB. And first part of migration is initial setup. So we are taking our existing data, which was used at MySQL, and moving to MariaDB. And what happens? First, check version compatibility. For drop-in replacement, that means you can just take data dir, and without making any dump and any just stop any dump, you can start MariaDB on it, and this work for this matrix, like for latest versions of MariaDB could be started on data dir created in 5.7 directory, but MySQL version 8.0 is different because in this version MySQL introduced new data dictionary and removed table definition files with extension FRM. And therefore, and since MariaDB doesn't implement this feature, it cannot just start on data dir of version 8.0. If you are migrating from version 8.0, you have to perform SQL dump and restore. So how to do drop-in replacement? So first, check version compatibility. If versions are compatible, stop MySQL server. Then install MariaDB server. Install MariaDB and then point MariaDB to MySQL data directory, for example, in the configuration file. Then start MariaDB, and this is important part. Run a MariaDB upgrade. And if you are using old versions of MariaDB, you can run MySQL upgrade. But in 10.5, MySQL versions of such utilities, the left were just aliases for new MariaDB utilities. So just run MariaDB upgrade. And here is why. This is example of data directory taken from version 5.7. And you see most of the tables use MySum storage engine. We have data file with extension myd. And some use InnoDB storage engine with extension ibd. Especially pay attention for those which are underlined in orange color. Because for MariaDB, it converts most of the tables to area storage engine with different extension, MyAD. And also it converts some InnoDB, not only MySum tables, but also converts some InnoDB tables to area storage engine. But not all, like for example, you may have like engine cost is using InnoDB storage engine. At the same time, MariaDB adds additional tables like column states. This is not full output, this is not full content of data directory, but still you have idea. So like if you don't don't run MariaDB upgrade, this conversion won't happen, and MariaDB at best will return errors, and it would not be able to use some features like column states, its independent table statistics. So like once you install it, like everything runs fine. So what you need to pay attention? You need to pay attention for difference between MySQL and MariaDB. First, it's specific MariaDB features. It's like storage engine, SQL statements, options, something else. They do not exist in MySQL. You didn't use them in MySQL, so if you need, it's probably the reason why you moved to MariaDB, so just use them. So there is nothing to discuss about. Another option is specific MySQL features. It's features which exist in MySQL but do not exist in MariaDB. It's either SQL statements or some plugins. They are missed, and there is nothing to do about it, so just just don't use them. But there are features which present in both products, but they work differently, or maybe like have same functionality but a little bit different syntax. And these are our focus today, because this is actually what you would probably would like to continue using, but you would use them differently in MariaDB. And first part, what we are doing when we connect to MariaDB Server, we authenticate. So first, let's discuss what is the difference between authentication for MySQL and for MariaDB. First, the initial setup, in that case, like if you are not operating, like just creating new server, MySQL deprecated MySQL install DB utility and removed it version 8.0 in options to use MySQL D and option initialize. But MariaDB didn't deprecate MySQL install DB and still uses it. And actually there is nothing wrong, it's nothing incompatible with it. It's just like just use this utility and they MySQL D initialize and MySQL install DB, we are doing the same thing. Both servers, both products support authentication plugins, so you can decide how you want your users to be authenticated. But they are different in both products. In orange colors, color I highlight what is exist in both products. This is native MySQL authentication plugin, and this is socket peer credential plugin. MySQL supports default SHA-256 or caching SHA-256, which is default in 8.0. It supports clear text plugin, which is allows client to, which tells client to don't hash a password and just like send them assist to the server. And also it has no login a plugin, which is could be used, for example, for storage procedures. Then it doesn't allow this user to log in. It just can be used like for storage procedures or for events. These are not supported by MariaDB. MariaDB instead supports MySQL native password. MySQL old password actually supported by MySQL up to version 5.7 included. Its old password, which is used prior version 4.1, is deprecated and used only for when you upgrade to very old versions. MariaDB supports SHA-256 on the client side only, so it can connect to MySQL service, but it doesn't support this plugin at the server side. Instead, it supports this plugin for secure connections, and this is for Kerberos. It supports PAM plugin, which is Percona server also has open source version of PAM plugin, and MySQL has commercial version of PAM plugin. MariaDB supports also named pipe as Unix socket, so you can connect from Unix sockets on Linux. User management SQL, like create user, alter user, etc., is the same as there is nothing changed, so you can just use it as use it in MySQL. But MariaDB supports multiple plugins per account, which MySQL doesn't, so this is kind of the extension and kind of advantage. Password validation, they work similarly, but these use different underlying software. MySQL uses in version 8.0 validate password component, and before it used validate password plugin, which is now deprecated, but it both regulated by the same options. So these are like password length, there is dictionary file, it should be path to this dictionary file. It's count of numbers, count of mixed case characters, count of special characters, and policy it's could be from it's like it's medium, it could be like strict or not strict. It's you can specify it. MariaDB supports two plugins, and one is simple password checks, which checks just length of the password and checks like same case letters, digits. So it works similar to MySQL, but it has different options and has different internal implementation. And another option is crack-lib password check, which has only option it's path to the dictionary. Again, it's like it's similar to MySQL, but it's a little bit different in underlying. But you can easily adopt your password validation policies when you migrate. Password expiration works the same way, so you can just set up like expired password as some tests. It's absolutely same syntax. Now for roles, roles is again the syntax is same, but it has different storage and it has different information about where you can find information about your roles. MySQL has 6 tables which show details about roles, and store roles definitions in tables user inside MySQL database, and also MySQL role edges which connect role with a user. In case of MariaDB, you can find information about your roles again in information schema, but it has less number of tables, just 2 tables, applicable roles and enabled roles. And also they stored in MySQL database, but it's same in user table, but roles mapping is in another table called roles mapping. And what is the difference? Its difference is that's when you create a role in MySQL, when you grant some role to another user, this role is not available for the grantor. Like if you are like kind of root user and you create some role, it's not in the grant to user like Sveta. This role would not be applicable for the root user, but for MariaDB, role automatically available for the grantor, so which we can see in the previous slide. So it's like same my role, it goes to the root user who has admin option and can do something with this role, grant or revoke it. And this is also applicable to user Sveta, which doesn't have admin option and cannot administrate this role. Another like common thing which we are setting up when we migrate is replication. It's practically for my all my support experience. I saw maybe 1 or 2 installations which didn't use replication. So this is kind of something which very basic and very important to do. Replication without global transactional identifiers, it's compatible. It's can work any way around, but again, this is not something which is recommended by MariaDB, but this is which I tested and I see it's like kind of works. But what you should pay attention for. First is data types are compatible. So like in case if it's some data type exists in MariaDB, but do not exist on MySQL or vice versa, you cannot use role-based replication. Version 8.0 adds additional complications, especially character sets, and we will discuss character sets later. And it's probably could be not trivial to create replication between 8.0 and MariaDB. For GTID, both products support GTIDs, but implementation is different. And MariaDB understands MySQL GTIDs, but MySQL does not understands MariaDB GTIDs. So only replication when MySQL is source is possible, but when MariaDB source is not possible. So like only replication from MySQL to MariaDB if you are using GTIDs is possible. For multi-threaded replications, it's supported again by both products, but concurrency control is different. For MySQL, it has option slave parallel workers. It's number of SQL threads which can run statements in parallel. It has parallel type, either database or kind of automatical logical clock. It also has bin-logged transaction dependency tracking variable, which also could be used for better management of parallelization of multi-threaded replication. In MySQL, in MariaDB, its options are different. It's called number of threads called slave parallel threads. Then for domain is for multi-source replication. And what is important is parallel mode is has not like kind of database or logical clock or write set. It has either optimistic or conservative or aggressive, minimal or none. So that means like none, it means there is no parallel mode. Conservative, it means it's most safe option, and like aggressive is less safe but most performant option. So you have probably to study and to find difference and to find which is the best for your application. Multi-source replication, it's again supported by both products, but it has slight difference of administrative statements. Like for MySQL, it's change master to master host source 1 for channel source 1. And in MariaDB, change master source 1 to master host source 1. Slave status for MySQL is default show slave status is for all channels. And if you want to see slave status just for single channel, you have to specify it. And in case if you, it also has performance schema, so you can also use this statement to query performance schema on slave status. For MariaDB, default is default connection, so it's default source. And if you want to see show slave status for all sources, you need to use show all slave status. So that's quite different, but otherwise it's works pretty similar. SQL differences. So like what is like mostly about how to work. We have like similar features, but you have to run a different SQL. So one of these is analyze, explain analyze, which is in version 8.0. So what is this? This is extension of explain statement. And explain statement by default, it doesn't execute anything. It's just estimates how optimizer will optimize the query. And in case sometimes it's telling lies, and sometimes you need it would be useful to actually execute the query and to find out which plan was created for the live query. In this case, MySQL uses option explains analyze and prints data in new tree format. It's available only in version 8.0. In MariaDB, similar feature available since a long time, but it's caused differences. So you can just like run analyze and put your statement here. And number of rows, it's actual read rows and actual filtered rows out of result set. Explain for the running thread also works slightly differently. For this example, I saw not very useful. I used not very useful select. I just selected like something sleep which run like for 100 seconds. And for MySQL, I use syntax explain for connections where I took process list ID from the previous slide. It's 2. And I get result immediately. For MariaDB, I'm using similar syntax. It's ID and 3, and I'm selecting only 30 seconds. In this case, show explain for free, it took 25 seconds. So MariaDB kind of may sometimes explain should take longer than case of MariaDB, and even sometimes fail with log wait timeout. So this function works, but this function works certainly differently than in MySQL. Histograms and table independent statistics. MySQL support histograms in version 8.0. These are collected on demand. Histograms, it's statistics which stored independently from engine, and store data for like if you have values 1, 2, 3, 4, 5, and you have like for the like if you have like store colors like so you have like three rows storing red color and 1000 rows storing blue color. In case if you are using indexes, you will have cardinality which is about half of the table, like 500 for both colors, which is quite not true. And for histograms, you are storing difference between like it will just like you can identify that table has only 3 rows with red color and 1000 rows with blue color. It could be useful when creating plans. MariaDB supports histograms for quite long time. It also supports kind of similar to index statistics, but engine independent way. And histograms in MariaDB, they are collected and used by default, so you do not need to have like in MySQL you have, if you need to have histogram statistics, you need to run analyze table and run to specify statement to create these histogram statistics. In MariaDB, they are collected by default, and they are used by default. Other statistics, not histogram-based statistics, it's collected on demand, so you have to run analyze table, but it's used by default if it exists. Functional difference, so difference in similar functionality. JSON, first is JSON. MySQL has special data type which contains JSON kind of optimized format. It also has functions which are not available in MariaDB. MariaDB has also, like, you can also create table with JSON type, data type, but this JSON data type is mapped to long text because, like, MariaDB ran tests and found that JSON data type doesn't have performance advantages for MariaDB Server. But when you specify JSON keyword in creating MariaDB table, this option is checking if JSON value is valid. It's automatically enabled. So, like, it's same as creating a table with JSON value as long text and creating check manually. And also MariaDB has functions which are not available in MySQL but available in MariaDB. But this data type thing, it creates some issues with replication. So it's for statement based, it works fine. But for row based replication, it cannot convert from MySQL JSON, cannot just replicate from MySQL JSON type to MariaDB long text type. Because these are different types, and you need to convert, like if you have source of MySQL, source service MySQL, you have to convert JSON data type to long text. Geometry extension is both uses SQL with geometry types of open this OGC consortium. This is both for MySQL and MariaDB. MySQL has slightly bigger number of functions, and I suggest you to check user manual in case if you use these functions. But otherwise, it has almost same functionality. Regular expression, both products support Unicode. MySQL support Unicode Science version 8.0.4. It uses ICU library and extended regex syntax. MariaDB supports Unicode Science version 10.5 and uses Perl compatible regular expression syntax. So these are like it's both are Unicode safe, but syntax of regular expression could be slightly different, maybe not slightly. So you need to check your regular expressions. And also MySQL has option keyword regex plug, which MariaDB doesn't have. Localization. Localization is character set. MySQL and MariaDB supports both similar set of character sets, but character set GB 18030 is available only MySQL. MariaDB has more collations, like 30 or 40 more collations than MySQL, but MariaDB supports not all MySQL collations. And this is why, for example, replication or importing dump from MySQL 8.0 has some adjustments, because default collation for UTF-8 and MB4 character set is not available in MariaDB. So you need to check your tables definitions and probably adjust character sets before migration. Diagnostics. For diagnostics, it's actually like I want to focus on two features. One is progress for alter table. In MySQL, it has this option in performance schema. And you may see like you are using invent stages current, invent like alter table. It's work completed, work estimated, and sometimes it goes above and just like some numbers when you cannot predict when actually the work finish. There are more stages than we are seeing on the slide, but when we are having example, it's probably like it's the stage which taken most of the time. For MariaDB, there are a few options to have progress of alter table. It's one is information schema process list is stage one. It actually has two stages, and here is progress in I believe in percents. Another option is use show process list. It's again has progress here. And third option is supporting client. So this is either should be MariaDB command line client, or if you are using some program, you may add this support to your program. It's described in the MariaDB manual. Not all clients support this. And in this case, again, you will see just like this stage of how much alter takes. Another issue, MariaDB supports this progress not only for alter table, but also for number of other statements, such as load data in file. And again, please consult the manual. But since we are talking about migration and MySQL doesn't support progress for such statements, I do not have supporting slides. Another, like in MySQL Science latest versions, performance schema is main troubleshooting source. MariaDB does like ports it from MySQL, which it finds useful, and it doesn't port everything. So what is missed? First is tables regarding logs. These are actually existed in old version even in MySQL, but in 8.0 it was moved to performance schema with adding additional columns. It's data log weights and data logs. In MariaDB, they are available for storage engines which support such tables. These are InnoDB, TokuDB, and MyRox storage engines. So like it's InnoDB logs, InnoDB log weights, and same for TokuDB and same for MyRox. Variables, there is no table called global variables in MariaDB, but they are available in information schema. Same for session variables. Variables info with information of variables available in information schema system variables table. And practically MariaDB has maybe even more information on variables than MySQL here. Variables by thread is not available in MariaDB. For replication tables, they are again not available in MariaDB. And in MariaDB, use show slave status to get this information. Error summary tables which are added in version 8.0 also not available in MariaDB, and there is no equivalent. Statement histograms, they are not related to optimizer histograms, which we discussed before, but this about histograms about how frequent such statement executes or how long it takes. It's again, they are not available. It's a kind of performance statistics on SQL statements. These are not available in MariaDB. User-defined functions, they exist in MySQL.func table in the MySQL database. Log status, which contains information about binary log and LSN of InnoDB storage engine, is again, there is no such table in MariaDB, but it could be obtained by show master status and could be obtained from show InnoDB status information about LSN, though it's not such convenient when using one table. So a conclusion. So initial upgrade is straightforward. Just take data directory unless you are using 8.0, MySQL 8.0, and just point MariaDB server to there and run MariaDB upgrade, and you are done. Feature difference are mostly easily solvable. So you just like either a little change SQL syntax, or maybe adjust your application a bit, but it's very easy. MariaDB has options which simplify migration, like you cannot replicate from MySQL source server even using global transaction identifiers, so you can safely migrate to MariaDB to explore all MariaDB advantages. Unfortunately, it would not be easy to migrate back to MySQL, so if you are considering option to migrate back, please do not migrate everything, but because MySQL is not so friendly for MariaDB specific options. This is slides about more details. It's mostly points to user manuals for MariaDB for specific topics which we discussed. These slides will be available online after the conference, so you can download, and these all are clickable link. But these are also QR codes. If you are curious now, you can just use your mobile phone that follow links using QR codes. And I put here links so you can easily use them like reference when you are migrating, so you can quickly find out what needs to be adjusted in your application. Thank you. This information about my where you can find me online, and the slides also will be at SlideShare a few dates after the conference. Thank you.
Thank you, Sveta Smirnova, live from us now in Alanya, Turkey. This is the first live section of today, so I'm happy to note that we actually had to interrupt you on your writing answers over Zulip. We have lots of Zulip questions and comments and proposed answers, and by both you and others. This is a hot topic. You picked really a hot topic to talk about, Sveta. So tiers. I'm thinking about what the reasons for the tiers are. So would you like to give a, shall we say, overview of the types of the hierarchy of the types of tiers? I think that well, a starting question might be this drop-in thing. What's your view on how drop-in we are in relation to MySQL? As on the other side of the spectrum, you would have to rewrite an entire application. So is it drop-in at all anymore, or just halfway drop-in, or what's your view?
Well, when I'm not saying like you have to rewrite your replication code. It's just like in case if you can very easily to move to MariaDB and use GTIDs. Actually, I like how GTIDs implemented in MariaDB better because they are more human readable. And so I understand what do they mean and what do they mean. It's not such cryptic as MySQLs. But MariaDB server can understand them, but MySQL cannot understand them, and so you cannot for example, have setups when you have multiple masters and slaves, and you cannot just mix them. You can just replicate from MySQL source, but you cannot replicate for MariaDB to MySQL if you are using global transaction identifiers. Actually, it's like when I was speaking about tiers, it's like when you use some features and you find out it works a little bit differently, and you are surprised, in case when you hit a live application. But if you are prepared, if you know that MariaDB is a similar feature, it works slightly different or maybe not slightly, you can just use it happily and without any issues. Speaking about difference of features, which MariaDB something which doesn't support, which is MySQL, and vice versa. Well, let's you choose, and this is like I always tell my customers, you need to find business reasons which features are more important for your application.
Right. Yeah. So GTIDs, global transaction IDs, that seems to be the most contested topic. And your view was that well, it's bad that they are different, or it causes a bit of headache, but they are more human readable in MariaDB. And I'm sure there could be a long debate on which chicken came before which egg and what's important there. So usually drop-in replacement means that you can start a new version or start a new MariaDB without changing anything. You just shut down the previous version and start the new one. I think there's a frequent comparison here about the size of an upgrade from one MariaDB version to another, or one MySQL version to another. comparing that with upgrading or changing from MySQL to MariaDB. Do you think that is a fair comparison, that you sort of a migration from one version of MySQL or MariaDB to another? Is it the same magnitude?
It's almost it's assume we are not using specific MySQL functions. This could be compared up to version 5.7, but as you saw in the start of my talk, MariaDB uses area storage engine for some tables for which MySQL uses either MySum or InnoDB. And this is why you need to be more careful when running MySQL upgrade. You cannot miss it. But still probably that could be compared. It's a different story happens when you want to migrate from MySQL 8.0, which introduced new data dictionary, which is completely incompatible with MariaDB. But so, and if
yeah, so what you're saying, I believe, what I'm hearing here is that if you want to avoid tiers, migrate when you're still at MySQL 5.7, because you will have tiers if you migrate from MySQL 8, that being based on a different type of storage. So is that a fair thing to say?
Yes, it's a fair thing to say. And also that's here it's a very interesting situation. When my slides, I wrote that MariaDB has far more collections, different collections than MySQL. But at the same time, default collection for UTF-8 character set in MySQL is not supported by MariaDB. And this way, it's even a simple dump from MySQL 8.0 to MariaDB would not work without correction, without changing. So you have to change table collections in default. If you are using default in 8.0, you have to change to another collection set explicitly. Only then you can make dump, and only then you can migrate to MariaDB. So this is quite of an extra step.
Yep. So you're saying that, first of all, the major tiers to avoid is the need to have to do a MySQL dump or a MariaDB dump, and all of that is doable or avoidable in all releases of MariaDB and all releases of MySQL up to 5.7. But then it's a case where you cannot migrate from MySQL 8 to MySQL 5.7 backwards either, can you?
Yeah, no, I cannot. I even cannot migrate between, it's not supported, and it's for some version, it's certainly, I cannot migrate from minor versions 8.0, like 8.21 to 8.16, I just cannot migrate.
Yep, so this is a typical thing for a MariaDB person to try to point out, that the incompatibility between migrations from MySQL 8 to MariaDB also exists inside, not just between MySQL 8 and MySQL 5.7, but within MySQL 8 as well. So those would be some highlights. I think the summary here is to do it before or up to 5.7, and especially beware of GTID issues, roles you pointed out. Those are, I believe, of course, less tiers, the roles and stuff, compared to the big picture.
Yeah.
So any final words on how to do the, on top of my sort of overall suggested conclusion from your speech, anything else you wish to say?
Well, it's actually that's it. So I would suggest you just like make sure about like study difference, be aware of them, and take them in account when you migrate.
That's a great summary. Thank you, Sveta Smirnova, live from Alanya, Turkey. Great job.
Thank you, Kai.
And now Sveta Smirnova will talk to you about modern solutions for modern database load improvements in the latest MariaDB server versions.
Hello, today we are going to talk about MariaDB improvements in the latest versions. First, before we get started, I want to introduce who am I. I'm a MySQL support engineer and MariaDB support engineer since I'm joined Percona. I'm author of book MySQL Troubleshooting, and I have a couple of hobby projects available on GitHub. I'm a speaker at various conferences, and today I'm going to speak about specific improvements which are unique to MariaDB Server. But before we get started, I want to remind you history of the MariaDB. MariaDB is fork of initially was created as a fork of MySQL, and MySQL first was released in 1995 by MySQL company. In 2006, Percona Server, that's one more independent fork, was created. In 2008, company Sun bought MySQL, and then in 2010, Oracle bought Sun, and as MySQL was part of Sun at that time. So Oracle now owns MySQL. In the same year, 2010, original creator of MariaDB, Monty Videnius, and main developers, they were not happy with situation. They just quit Oracle and created own company called MariaDB. MariaDB started as fork of MySQL, but now it's independent product with hundreds of unique features, and which features are very different. Some MySQL doesn't have. But important, since origin of both products is the same, important improvements are backported from MySQL. So MariaDB has most important features from MySQL and also has own unique features. In this talk, I'm not going to talk about features ported from MySQL. I had another talk in past, and it's available online. So if you are interested about MySQL 8.0 features, you can watch a recording. And for those features which are backported to MariaDB, it's also applicable to this product. But in this talk, I'm going to talk about MariaDB unique features. And MariaDB unique features is mostly like I put into two groups. One is optimizer improvements, because MariaDB has a very strong optimizer team. And for example, MariaDB introduced advanced SQL such as Windows function or common table expression many years before MySQL did it. It also MariaDB is unique that it supports a big number of storage engines and other storage improvements such as data types. And this is focus arm of my today talk. And one of first feature which I want to discuss, it's called storage engine S3. This, as you can guess from the name, is data is stored on Amazon S3. It's very easy to convert. It can be used just like you are using alter command for and converting any storage engine table to use Amazon cloud storage. But underlying engine is area, so like it's practically you are converting your storage your table to area table, local area table, and that area table goes to Amazon S3 storage. These tables are read-only, and so that's a unique case for because you probably do not want to write much for remote storage, but for read-only, for cases like in case if it's not frequently used data, but you still need to store it and you need still to keep it on a comparatively cheap storage, it's the best case to use this. It also has unique features, so it can use shared storage and separate and shared storage for replication. Like separate storage is like in case if you are setting up it's the same like you are setting up source server and replica on the same machine, like for example, if you are testing it's a laptop, but it's copies, like you have one copy of data directory for the source server and one copy for replica. But for S3 storage engine, you can also share this data. So you can have only duplicates for tables which do not use S3 storage engine. It has own layer to connect to S3, so it's not shared API, it's own layer called libMaria S3 library. Another unique feature is column store, which is available since 2017 as a plugin. It was available in 10.4 enterprise version, and now it's part and it's included and shipped together with 10.5 community server release. This is columnar storage engine based on InfinityDB. But what is unique about this storage engine? It's has SQL interface, and it's can communicate. It can be joined with SQL engines such as InfinityDB. One of common pains of people who have like heterogeneous environments or who move from SQL to columnar storage or vice versa, they have to set up jobs which get data from SQL storage to columnar storage, and they cannot combine them, and they have to maintain two copies and have to maintain them synchronously. But with column store, you can it's just like built-in, so you can have advantages of your SQL storage engine, and you can switch and you can use this columnar storage. MariaDB has many more storage engines, and here these are QR codes. So you, like, if you are watching here, you can use your phone and you can access links. Or after the conference is over, these slides will be available for download, and they are active links, and you can just follow these links. I do not explain about this storage engine in details because these are not new, comparatively not new, and well, if I do, it would be quite a longer talk. One more important feature of MariaDB is system versioning tables, which actually then when I joined MySQL as support engineer in 2006, and I was on my first MySQL user conference, many people describe it watches how to use, how like rollback changes into database, and for that time it was not like quite useful. You have to like maintain log and to make like application label. But in system versioning table, you can use like your repository, like GitHub or like any source tracking version tracking system, and your tables have history. And you can perform, for example, point-in-time recovery on the fly. And I have here example. In this case, I'm using standard test database employees. It's available at MySQL website or actually on GitHub. I just like take it and change the table employees. So I added system versioning. So that's now it's standard employees database supports versioning. And if I run show create table employees, I will see it's just normal InfinityDB table, but with this option, with system versioning. So what does it mean? What does it mean? It's like usually for queries, we can query it's like any other table. Like we can select, we can change rows. And mistakenly, I run delete from employees, and I removed all employees which was hired before 1986. It's a pretty large number. I thought first like, oh, maybe it's a mistake, maybe I didn't do it, but practically I do it after commit is one, so it was committed, and I do not have records in my employees table with these employees. So what can I do? With system versioning tables, I can query time. It's like since I it was just like now. So I took a period when I knew that my required record exists. So I just query insert, query my implies table for system time between now and interval 1 hour and now, and where hard date it equals my condition, and I just insert into implies table, and I have all my removed rows back. These system versioning tables, they are very tunable. So you can store not only time, but you can also store transaction ID. You can have history stored separately, for example, if you want to have maintain it in different physical spaces. You can partition your regular table data in one partition and your versioning data is another partition. You may exclude some columns from versioning if you do not want them to be versioned. It's also possible to have time-specified time periods at application level. It's a little bit different syntax, and I did not cover it here, but you can do it. And you can combine both, system versions, like I showed just now, and application period levels. And for another feature, it's also useful for previous one, so it doesn't show versioned columns. It's invisible columns. So what does it mean? Sometimes you may have a table with a large number of columns. Here, I want alter table employees and add a column address, which is JSON format, which is quite long and which can probably may have some even more than one address, or maybe for some employee it can be just country and a city, and for another employee it could be quite long. And also many could not just could not specify, just like I just started, and I not always want to see it in my output, and you can have many such columns. In this invisible columns are not accessible for queries like select star. So you are seeing here, it's just implies table we saw in previous slide, but there is no new field. But if I query a new field directly, it's accessible and it can be visible, it can be used, and it also could be used in the functions like I'm using here in JSON extract. Another MariaDB improvement is sequences. Sequences by default, MySQL and MariaDB tables supported only after increment columns for sequences. So you can have some ID column which started from 1, and then depending on after increment option, it's will create such numbers. But sometimes you want, but you can only have one after increment column in the table, and sometimes you want some custom sequence numbers. In this case, you can for MariaDB you can create a sequence. It's was possible to imitate sequences, but it's always you have to create a table, you have to maintain, you have care about transactions, about atomacy. With MariaDB you can just create a sequence, and for my example, I create circles with odd numbers, which starting with 1 and incremented by 2, so it should have 1, 3, 5, 7, etc. And another sequence called events, starting from 2, and it is again incremented by 2, so it's 2, 4, 6, 8, 10, etc. And I created table numbers where I put primary, after incremented primary key, and 2 more columns with odd and even numbers. And here we can see its syntax. So default value, it's next value for the sequence name. So this way we can create table and have customized sequence numbers in there. And in case I put just empty, something to insert everything default. And this is I'm having this is after incremented ID. This is all our odd numbers and our even numbers. So it's pretty easy. It's very useful. It's can be used for situations when you cannot use standard after increment features. Another feature is both MariaDB and MySQL for a long time support IP version 4 support, have functions for it. And MariaDB has a new data type called inet6, and which supposed to store IP version 6 addresses. It also supports IP version 4 addresses which are incompatible, which has deprecated format now, and also mapped. It's a little bit like it has this prefix, and this is not deprecated, and this will be supported. It also supports functions which is for IP version 6, and like I put here IP version 4 compat is to find out deprecated addresses here. So it's more effective way than just store these IP numbers in strings. And also it's more effective if you can, for example, compare to IP addresses. Another feature is wait and no wait interface for statements like querying tables or even for DDL operations. So what is this? With a normal stable scan, like if you have 5 rows here, and one thread is doing some work and just logs, like for example now row 3, and second thread is doing scan, and it meets rows with ID 3, and then it waits. It's depending if it's an DB storage engine, it's DML query. It's in a DB log wait timeout seconds, or if it's DDL, it's waits log wait timeout seconds. But this is not sometimes what you want. For example, by default wait timeout could be set too high, and you want to wait less time, or vice versa, it could be set too low, and you want to wait more time. So you can just specify how many seconds you want to wait. You just add this to your SQL statement, and MariaDB will wait this number of seconds. And then either error or either read for rows. If you do not wait, you can specify no wait keyword or just wait 0, and your query returns immediately with error. And this is very useful because default, for example, DB log wait timeout, minimal value is 1 second, and 1 second it could be very long time. Like modern application can easily handle 100 sorts or even transactions per second, and this could be way too long to wait just 1 second, and it's much better to have error immediately. That's like kind of finish of discussion of storage and related improvement. Let's discuss SQL and optimizer improvements. One is aggregate storage functions. This is your own aggregate functions. It's sometimes like you are doing like you may miss some aggregate functions which works in group of row, and you now can. And before you could only, like if you wanted to create your own aggregate function, you have to learn C language and write UDF function. But now you can just create your own aggregate function yourself. To do it, you need to add aggregate keyword to the function name. You need to specify value. This is value which would be used for this function. And data type, like for my example, I use integer data type, but for your case, it could be any data type you want to this function work for. And for this function, I count positive values in some column. You must declare exit handler for not found condition, and you usually return the result of this function, but you need to just return something from here. And then in the loop, you can create loop, and you also specify fetch group for next row. So you are fetching next row, and you have access to value, like to the value, and you can do something with it. So like in my case, I check if value is positive, and it's positive, I increment result. And let's see how it works. In this case, I have a table called numbers, and I have some numbers in num column. It's some are positive, some negative, and one is 0. and I have some color which I want group for, and I have like for this color I have these numbers of positive and negative options. So you can see it's 1, 2, 3, 4, 5 positive values. So this is sum is correct. So this is how they are distributed, and you can tune and you can create aggregate function for whichever you like. And here it's like this is like these are feature which I discussed. Those features were introduced in version 10.3, 10.4, and 10.5. But I want to speak about these pretty old functions. But why? Because the another talk which I referenced before, it's about MySQL 8.0 improvements. It shows similar improvements. But for MariaDB, some of them existed for very long time. For example, roles were introduced in 10.0.5 version. So, but I still want to show them because, like, in case if you missed these options, and these are pretty modern and still interesting and very powerful to use. First, I want to speak about histogram. Histograms. What is a histograms? Histograms is not storage engine statistics. So, like before histograms, we had one way to use statistic about what is stored in our tables is indexes. And what is the problem with indexes? So, assume we have a table with 10 different values with data distribution. Like with value 1, we have pretty large number. With value 8, we have pretty small number. In case of indexes, we have only one value which could be used by optimizer. It's called cardinality, and this is same for all values, no matter which one it is. It's actually practically both engines, and MariaDB also has engine independent statistics, have some extensions which allows to access to have more ideas about ranges of data here. But still, it's like just a simple way. For index cardinality, it works so, and sometimes it could be not useful. It's not possible to find out which index is better to use, because we just for us it's same. It's like this number. It's big number of unique values of values here. It's small numbers here. For us it's same. For histograms instead, they store information about unique values for each range. So in this case, we may like see its equivalent to 1. It's probably to 8. So that's smallest number of values and this biggest number of values, and we can see difference, and we can have optimizer can have better decision which which query execution plan to create. Another option is analyze statement. Which is a problem? It's when we are trying to find out how our query is executing, we are running explain statement. But explain sometimes telling lies, not because it's poorly designed or not because it's poorly written, but because it doesn't execute query. So it's just like it's estimate. So it's like it doesn't execute anything. It just thinks which optimizer will use when resolve the query. And for example, for this query, we are searching for 3 rows, and optimizer tells we are going to check 33 rows and use this this optimizer plan. But practically, when we execute the statement, it could be run slower. And analyze, it's the same as explain, but it executes the statements. In this case, we have more accurate data. So in this case, we are saying we examined practically 100,000 rows. And here it's R rows and R filtered columns. R rows, it means it's actual number, which how many we examined. It's 100,000 rows. And R filtered is how many rows from filtered result set were left in the resulting statement after where clause was applied. In our case, it's no zero, but it's practically not zero, but it's like sign free. It's probably free. It's just like it's percent. It just was rounded up this way. So it's like if it would be like limit 33, it would probably have 0.0.1. Another important feature which I want to show you is common table expression. It may look complicated. It's kind of modern, advanced SQL, but it can make your life of SQL query designer it's much easier. So what we are doing here, we are using with keyword. We create a name of our result set, and we are using like kind of subquery. And then we can refer this subquery from our object query, and we can join with table with any other table, or with we can join with like depth data. With depth data, we can create as many such clauses, such named subqueries as we want. We can refer that 2 times, and it's makes it much power SQL, and it's much easier to read than if you use like traditional subquery which were available before. That was not recursive common table expression, but MariaDB supports also recursive. That means we can refer to result by itself. So how can it be created? You need to create it with a recursive keyword. It's name of that expression. These are 2 values. And these are initial value set, and we are selecting with our expression. So we're selecting ID from 1, and we increase it. And a second value is random number. And here is expression which limits, because this is loop. And this loop should start somewhere. So this is important part. We need to limit it somehow. And we are selecting from our generated data, and we are having like some table with random values. So that's kind of useful feature. Another advanced SQL feature is called window function. It's again is better to show on example. So we have like a very common case. We have some result set, and we want to have numbers which are incremented like ID. And before window function, it was pretty hard to do. We have like create some tables. You maybe create join. It was like just too complicated and sometimes hardly possible. But here you can select some data from select some data, and you can add function for this window. In this like called row number. In this case, we are just adding number of row, and with this function we select a unique name like ID. That's called window some random name for our window. And here we are using order by our one of columns, so we have our result set ordered. It's like you have to sit with it, you have to learn it, but after that it's writing SQL it's much easier than was before. Another like long awaiting feature, it's again available in MariaDB for quite a long time, is check constraint, which helps to create custom rules violation. Without check constraints, you can just like use like kind of triggers, errors and raise error. But with check constraint, you can just like write a table and see like expression, and you want its expression to be true. Like in our case, I want to check like its value is even, so it's a modulo by 2 is equal 0. So if I insert even values, it succeeds. If it's not, I'm receiving error, and that's error not succeeds. And finally, it's important for privilege management. It's roles. For like what is like common MySQL DBA pain is to like if you need to add many users, you have like for example. If you have like similar, you just like want like read ability for regular users, and you have to for each of them create like grant statements. And as a result, I'm seeing like as support engineer, I'm seeing people just like grant more privileges than this user need, and this creates security concerns and security issues in future. With roles, you can just create roles and you can grant specific privileges to roles. Like, for example, I created read-only and admin, which has super privilege. And then I created a user, like just regular user. We are humans, like Sveta and Kai, and some administrator user called privileges. And I grant read-only to Sveta and Kai, and I grant admit option to privileged user. MariaDB also support default roles, so these are either default roles for a user or default role for any new user which you create. So conclusion, to conclude our talk, that's new versions have new features. MariaDB is unique that it implements advanced features very early and very fast. So upgrade to new versions to explore all MariaDB advantages. And here is more details. They are practically mostly links to the user manual. This is the FOSDEM talk by Sergey Golubchik on system versioning tables. This is MariaDB Day near FOSDEM 2020. It's talked by S3 storage engine after Monty Videnius. And others are links to the user manual. And again, it's more information about discussed features. More information about checks, constructs, and roles. And all data will be available on SwitchShare and unknown server Twitter. Thank you.
Thank you again, Sveta Smirnova. Great presentation, great summary of the new features. I have a couple of questions about these for you, but before that I have an announcement. Usually at conferences, the presenter, moderator is saying where the toilets are and when there will be food. Well, I cannot help you with those, but what I can help you with is the fact that there will be a break, a coffee break. That coffee break is happening after the next presentation. So there is a back-to-back presentation by Tera Zhou after this, but then after that, there will be a 5-minute coffee break. So those of you who are listening to all of this back-to-back, which I very much like, you will have a break. But now back to you, Sveta. So I quite like the overview: S3, column store, system version table, sequences, IPv6, CTs, roles, window functions, and aggregated functions. What I'm thinking about here is, as a user, I would ask myself, why were these introduced? So you did a good job of presenting what they are and what they're used for, but do you see any sort of grouping here? Why do you think that these features were included? Let's start by, so I have a guidance here, or somewhat thinking along the lines of some of them are done because they exist in other databases, or they are copies of logic that other databases are created for. And I would assume you would classify column store as one of these. So, or how would you group this question? Why were these features created?
Well, it's actually depends on the feature. And if speaking about column store, for example, we have multiple column storage databases, independent databases, which are independent from for example, ClickHouse, or like other column store databases which are used great for analytics. But issue with them, that's even if they support some kind of SQL syntax, it's sometimes it's kind of migration with many, like for years, for dozens of years, for 20 years, people store data in SQL databases. They just cannot just take this data and just cannot move it to analytical storage. It's also that SQL databases, they are great for traditional use. That's like for web applications. So again, people would not probably want to make this move forever.
and switch to this column storage and learn. It's also migration. It's all migration planes. And for column store, that is great, which is like a great feature of MariaDB. It's can understand. You can talk to it with SQL syntax, which you use it to, which you work with MariaDB. And we have, like, if you want to, like, for example, compare it with other column store columnar databases which are independent from database server. Search Percona website, Percona blog website for blog post by Alex Rubin, where he made benchmarks and used real use cases, which is showed then MariaDB column store has advantage. And this is most advantage that it understands SQL and it could be used together with less pain of like with supporting to different storage for the same data. If speaking,
I think what you were saying there is that you were answering even more than I was asking. Why my question was why were these introduced, and I read your answer saying because they are useful in general. There are other products that have this feature, but these other products are different. They're not necessarily based on SQL, and there are clear advantages of having access to that functionality from MariaDB itself. And I was mentioning columns, and you had that as a great example. So what about S3? How would you? Why do you think that one was created? And any speculation?
For S3, there is a different case. It's very common case actually. That's people. Many, like I have, like from all my support experience, I have people who create tables, and then I joined it. I started working as MySQL support engineer. Was modern version 5.0, and then 5.1 with MySQL 5.1 with partition support was introduced. And many people started to use partitioning, and before they use it archive storage engine, they just like have data. It's actual data. It's like 1 month, for example, like 1 month of like financial records, or maybe popular blog post or something like this. And other data, they still need it. It's still required. It could be used for analytics, or for maybe if it's case of like, if it's like some content which user create, which some users who like to go deep in history, but it's not would be so actively used as actual data, and certainly would not be modified. And people just use it partitions and archive tables. But what is the problem? It's storage. It's like if you like go it's on internet, I just like don't have this link in my mind. But if you go on internet, you may see how big the data which stored in web is how it increases. It increases exponentially over years. And having like supporting local server, like having like a small amount of data on your local machine, and which you need, and have terabytes of data which you, and maybe sometimes even petabytes, which you have to, you still need to store, you still want to have it, you want to be it accessible, but you don't need it all the time. And you can like survive some penalty when accessing this data, but you want to have its storage. And you can explore with cloud storage with S3. You can explore advantage of it. It's very flexible. It's could be used, and it's not so expensive like if you do it for that's fast storage which you need for your real life application.
Exactly, great. So if column store is about accessing functionality that there are totally different products providing, and then giving access to that functionality through MariaDB, with S3, it is a need that has already been satisfied by, as you say, partitions and by the archive storage engine, but it is a modern version of that, and it's a cloud-based version of that. So in my world, I think there are 2 or 3 scenarios here. One is about giving access to functionality through MariaDB of what other products have, and then one is about modernizing features such as our archive, giving it access over cloud, And then compatibility, making it easy to migrate from other tools which have certain functionality. And I think your IPv6, CTEs, window functions, all of that are in that scenario. What some concluding words from you? We don't have many seconds left.
It's all the features. At least all the features which I put here in the topic have reasons to be introduced. They have underlined use case. They have pains in previous situation when people survive. I actually probably like that you have very good idea how this tool could be improved. So like explain which are pains they solve and why it was introduced.
I think you did a great job. This was not an improvement suggestion for your speech at all. So thank you, Sveta Smirnova, for a great presentation.
Thank you. Thank you.
Our next presenter is Tera Zhou. How to help financial customers use Tencent Cloud MariaDB.
It's my honor here today to take part in the MariaDB Server Fest online conference. Before we talk about our topic, first let me introduce myself. I'm the product manager of a Tencent Cloud database team, and I once was a developer and for 7 years, and then I became the product manager for 5 years. So I've done this job for 12 years. Today we're going to talk about how to help financial users to use Tencent Cloud MariaDB. I think we there have 3 aspects to talk about. First is why we choose MariaDB, and I think this problem maybe can stem from why we choose it before we start up Tencent Cloud. Before we provide the database on the cloud, we actually use MariaDB for our account information, and then we provided the database to our customers in Tencent Cloud, and they have some requirements. We will talk about what we do to satisfy their requirements, and meanwhile how to enhance MariaDB. Okay. Why we choose MariaDB? I think there are nearly 4 reasons why we choose MariaDB. First one is new features, not just MariaDB 10.5, 10.4, but at the very beginning MariaDB have some features that MySQL don't have it, or they have it, but just in the enterprise version, such as the thread pool and some grammar, or in the latest version we have S3 compatibility, but MySQL don't have it. Maybe it will have it later or never. Another one, MySQL don't have some engines that we have it in MariaDB, such as MyWorks or Column Store, and some other engines such as Cassandra. So we like it. Use MariaDB for some new features and some engines that will never happen in MySQL. And some other reason, maybe it's not some technical reason, but it's also very important. And sometimes that will make users to choose which one will be their best choice. First is the license. MySQL, there's some of their drivers under LGPL, and MySQL is under a commercial database company. Maybe there has some potential risk for us. So I think every user and every cloud provider have to consider it. And another one is open. Me and my colleagues have participated in several MariaDB conference. We've seen the decisions can be reviewed and debated, and we can talk about what we're going to do in the next version, and we can talk it with the developer, with Monty, so we like it. Okay, the last one. But we put the database on our public cloud and private cloud. We have more and more users, and especially the financial users. They have a lot of requirements. such as security. We have users from bank, from insurance company, from securities company, and they care so much about the security, not just themselves, but their supervision organization, some bureau, or some other organization from their industry, and they have a lot of data, and the data will accumulate from year to year, and we need to scale out the data, and we need to update the database without interruption, and they usually have one active node and two standby nodes, and also have some disaster recovery nodes from 1,000 kilometers away, and they need to have high availability, more than 99.99%, and they would like to use some window function, some CETS, such as the grammar in Oracle. So there are a lot of requirements. We will do our best to satisfy them. We need to first look at our architecture of the database. Here we can see there is a meta cluster. The meta cluster stores all the information from the proxy, from the instance, from the agent, from the physical machine, and from some other component. And here is the OS. The OS provides the APIs for the Red Rabbit Manager, and then users can use the Red Rabbit Manager to see how many instances here, what's the status of the instance, and what's the IP and port, and how about the status of the instance. And also we have a schedule manager, and the schedule manager will use the metadata to decide which one is alive and which route is right, or which proxy is right, and how to get rid of a node. And also we have some code backup center, a message center, and here is the LB. If we provide this in private cloud, this LB maybe it's hardware or LVS. When it's in public cloud, it's a component in the public cloud, so we call it VPC gateway. Okay, the first one we want to talk about is security here, the security. Okay, and there are three phases when we talk about the security. The first one is before the SQL come to the engine. We can see the connection here, so we need to encrypt the connection, have some authentication, and when the SQL come to the kernel, we have a kernel level security policy or SQL firewall. Here we can see in the proxy we can configure the SQL firewall, and maybe we have another misoperation prevention here to get rid of some bad happen. And after that we have the audit. Okay, here we can see the audit. First, the user needs to have some audit rows. We can have a regular expression, what SQL we include or not include, what SQL we equal or not equal client IP or execution time or users. And then we combine this row to our instance. And when this audit row happens, what we do to let it go or have a non-message for users, and then we get a audit log and see, so we can check a log and we can have some analyze for the log. Okay, another one is high availability. We talk about this. Users have more than 99.99% requirement for the availability. Here we can see another number here, 1, 2, 3, or 5, 6, 7. I'm going to talk about what's that mean. Okay, for the one step, the active database is downgraded to the standby. Maybe it's because some bad happened. You can see here we have active, and every active and standby means a process. This is MySQD or now MariaDB process, and every process have an agent. Here the agent gets another information from the process, and we put all the information to the metadata. Remember to talk about it to the metadata cluster, and the schedule load the data, and they know what happened to the master, to the active. So in the first step, the active database is downgraded to the standby. Maybe it's called down or something bad happened, and then in the second step, the standby report is the latest byte log location, and when they report the location, the schedule know which one is the latest location, and then the standby merchants can participate in the election, and then we in the fourth step we reconstruct the master and the slave, and we modify the routing rule, and then the request from the proxy can directly to the new node from this one, and to the new node. And the entire switch process is fully automatic without human intervention. And so the strict handover process, we use this to ensure the data consistency. Okay, and another one. You can see this one high availability is happened just in one data center. But if we have more than one data center, so we need to have some other ways to fix that. In this example, we have 3 data centers, 1, 2, 3, and the active and this standby is in data center 1, and this standby is in data center 2, and in this data center we don't have a standby, but we have a schedule node. We have a meta cluster node here. So when this data center have some network problem, but this data center don't know it, and so this data center don't know what happened in this data center. Maybe it's a network between the 2 data centers interrupt, or all this data center is fail over. So we need to use the schedule between the schedule all across the 3 data center to judge what happened, and we use this to avoid the split brain problem. Okay, if the network between the data center 1 and data center 2 is break, and we know because we have data center 3, so we can't connect to this data center, this schedule, but we have this and this, so we know what happened to data center 1. Then we get rid of this schedule node, and then we can have user data from their client to this data center. But of course, this maybe can't keep the consistency of data, but it can give a high availability. Okay, the fully replication. We will talk about this. Users of the financial users like fully replication because they want to keep the data between the standby and the active node is the same, so they can read the standby or read the data from the active node. Maybe that will affect the performance, but they can accept it. But for the full replication, before we did this work, MySQL don't have the fully synchronous replication, but now they have it. They have it in MySQL 5.7, and but still we have some advantages here. We have our asynchronous threads group. In MySQL, with fully synchronous replication, when a source commits a transaction, all replications must also have committed the transaction before the source returns to the session that performed the transaction. Fully synchronous replication means failover from source to ending replication is possible at any time. But the drawback of fully replication is that there might be a lot of delay to complete a transaction. So we do a little work here. We have a synchronous thread here. That means in this place here in number 1, in MySQL, they just put the date to the biolog and the data here from the step 2 and to the running log, or apply to the file, and then this thread just here to wait until there is ACK come back to the thread. But here we have a threads group. The thread just send the data to the standby. It's not a semi-synchronous. We just we use this thread to do some other work. But when this come back, when this ACK come back from the standby and the thread gets the ACK, and it will be wake up and to send the data back to the user. So the thread here is always doing the work, but not like MySQL to wait until the ACK come back. So it will always work. This is what we do for the fully replication. We call this asynchronous thread group. Okay. Another one is multi-source synchronize. This is used for our insurance company. We have, a lot of insurance company have some subsidiaries. These subsidiaries maybe use their database is totally different from their head office. Their head office maybe have use MariaDB or MySQL, but the subsidiary use Oracle, MariaDB, Postgres, MySQL, not the database. So they need to compile this data to their head office to do some analyze work. So we use the biolog extraction, and we pass the biolog, have the materialize the view log from the Oracle and put all the data to Kafka, and then there are some consumers put the data to MariaDB and or to some other databases. This is what we do for the multi-source synchronize, and then we have for data verification. We to keep the data right. Okay. Another one is DBAs. We have DBAs for MariaDB and some other database in private cloud and public cloud. There have monitoring information and before and provision components, and analyze or have a user to analyze the database, to analyze the performance and maybe the dialog, and also have some alarm message for users. And also we have some tools for users to fix the problem and have some emergency response components. And also we have a optimization report for users to modify their schema, modify their index, and something like that. And we have more than 70 monitoring information and have 5 grade did monitor information, and we have audit. We talked about this before, and we have performance check program and security threat and a non-message, and we help users to queue session and help users to optimize their index, have some expert advice. Okay, user cases. This is your case from bank. Here in this bank, they have 3 regions. The first one is Shenzhen, another one is Shanghai. Shenzhen is the head office of Tencent. This bank has 3 data center, and the 2 data center is in Shenzhen, and another data center is in Shanghai. They have 1 master and 2 slaves in Shenzhen, but these 2 slaves just in another data center, and they use fully replication here. And also this master have a read-only node, and their clients read the data from the read-only or the master, and the slave here can't read any data from here. But if some failure happens, they can switch from the master to the slave. And here we can see in Shanghai it have a asynchronous replication between the slave and this master. So use this asynchronous to keep the performance, and we here use the fully replication to keep the consistency of the data. And here we can see Shanghai and Shenzhen, we have a long distance. This means this 2 node actually is a disaster recovery node. This is what this bank deployment. Okay, thank you.
Our next presentation is by MariaDB Foundation's very own Vincenzo Ciorbaru. Long-term archival with MariaDB's S3 storage engine.
Hello everyone, my name is Vincenzo Ciorbaru. I hope everyone's having a great fest. Today I'm going to talk to you about the S3 storage engine, which is a way to archive data within MariaDB on an S3 service. So what does S3 stand for? Well, it stands for Simple Storage Servers, and it's a way to store files in the cloud. It uses the HTTP protocol, primitives such as get, put, or delete. And with these, you can send any file into S3. This makes it ideal for archival purposes, but it's not very good with lots of small files. Actually, the ideal file size is around 4 megabytes or so. And this is important because if you want to access your data, especially if it's spread out around small files, you're going to incur a lot of performance overhead, namely with the network transactions. So this sort of service is implemented by many different providers. The original specification came from Amazon with the goal of providing data with millisecond delay and cheaper storage overall, especially if you access your data less frequently. So that's the goal of the service. Let's see how we managed to do this with MariaDB. So MariaDB implements now a S3 storage engine, and it is a way to interact with an S3 storage backend. With one simple command, you can move your tables from a production or operational level storage engine like InnoDB into the archive version of S3. By doing this, you get them as read-only tables, but you can use them as any other select. The S3 storage engine is built on top of ARIA, and there is one key advantage to building it on top of ARIA, and that is that you benefit for free from all the optimizations that ARIA supports. And on top of that, it also works with partitioning. There are some specific optimizations for S3, such as compression and a very useful table discovery that lets you access the data from multiple servers at the same time. And to be able to reduce network latency, it also has its own dedicated page cache, which is configurable. So let's see how we can use the S3 storage engine. The goal when it was first designed was to make it really simple to use. And all you need to do is configure where the S3 provider is. So you need to provide the host name, the S3's region, in case it's a cloud-based with multiple regions. Then you need to tell it the bucket name. And finally, just provide the access key and secret key credentials that the S3 provider supplies for you. Once you start up MariaDB with these settings and the plugin enabled, all you have to do is pick whatever table that needs to be archived and change the storage engine to S3. Changing it to S3 means that all the data from your production table moves to the archive. And that's all you need to do. Now, it's important that you understand a little bit of how the storage engine works behind the scenes, because then you can more easily reason about the performance implications. So behind the scenes, we first tried to implement the S3 storage engine like by using the Amazon SDK. Unfortunately, it didn't really go, it didn't have the API necessary that we wanted to use. So we ended up writing our own. We have a small library called libmaria S3 that behind the scenes uses libxml and libcurl for the networking aspects and the parsing of results. And with this library, we have some logic on top of ARIA. Now, the way things are stored, and because it's built on top of ARIA, you're going to see some similarities. We store in S3 each block as a separate file. And blocks are the size of that's specified as a parameter, and it's usually 4 megs in size. Now the table definition still holds an FRM, and here you'll see, here's the example of some files that you can find on S3 once you've moved the table. So you're going to have the FRM, which stores some metadata about the table. You're going to have the first index block. It's going to be called ARIA. And then subsequent index and data blocks are found in separate paths, the index and data paths. The numbers here you see are prefixed with zeros. The number of blocks is not limited to 6 digits. You can have more. We just chose to prefix a few more zeros just for easier reading, assuming tables are maybe roughly around 4 gigs in size, or 400 gigs actually. Now, with this in mind, let's think how we could do replication with S3. So the server can be configured in 2 ways. You can use the same S3 storage on both the primary and the replica, or different S3 storages. So if you're using different S3 storage, there's really nothing you need to do. Every action that happens on the primary server has to happen on the replica. So regular replication will work just fine. The problem with this one is that you end up storing your data twice, and especially for a already high availability backup service, you don't really need a backup of the backup in this case. So the more favorable system is the one with a shared S3 storage and multiple servers used as a replication chain. Now, the problem with this one is that the replica server needs to do things a bit differently. Some transformations need to happen, and these are that whenever you convert a table to S3, when the information gets to the secondary server, the table is already there. So all the secondary server has to do is to drop its own production level table. And then thanks to table discovery, the S3 storage engine will find the table stored in S3. The reverse operation, where you're trying to move from S3 back to a operational data, the table has already moved by the time the replica sees the alter table command. So instead, the replica, all it needs to do is to drop the instance that it knows about of the S3 instance, and then it needs to recreate the table as the destination storage engine. Unfortunately, this means that the replica does not have the data yet. Luckily, the master will send all the rows to it, so it will just insert all the data via regular binary logging. Now, you need to keep in mind that MariaDB is by default configured to assume separate storage, which means that the 2 relevant switches replicate alter as create select defaults to on. This means that all the tables rows are logged into the binary log, and then the slave will ignore any updates that happen to S3 tables. Now, this is what you want when the storage is separate, but if it's shared, the S3 secondary server must make sure to ignore any updates to S3 tables because the updates are already there. And in case you are in this sort of configuration, you need to manually set your slave to ignore updates. All right, so that's about it for replication. Let's see some details of how we could make use of S3 in practice. Well, you need to take into account, like I've said before, that the speed of these tables depends on your internet connectivity. So there's no way that the first access can be faster than how long it takes for your internet to fetch the first block, the ARIA block from before. Follow-up accesses will hopefully have the blocks in the page cache, so they should not have to go over the wire to get your data. But just in case this is not enough, to speed it up, you can compress your data. And by compressing it with the compression algorithm equals zlib, a switch for the S3 engine, then the amount of data stored in S3 is just the size of the compressed block. So that's a gain there. And in case that is still not enough, you can choose to increase your page cache. That way you can store more blocks in memory, and you probably have to go less via the network. Now, because all of this is a network-based system, you need to keep an eye on network traffic. Usually, S3 providers will charge for your network traffic, which means that S3 tables are nowhere near suited for operational use. However, they're very good for analytics and also infrequently accessed data like backups or disaster recovery situations. By choosing to compress the S3 tables, you reduce both storage and network costs, but whenever you use the tables, you have to do some more computations internally, so you might be CPU bound in that case. Although it's probably not something you should worry about, just something to keep in mind. All right, enough talk about features. Let's see how this storage engine works in practice. Let's open up a terminal and see how we can make use of S3. All right, we're at the terminal here. So what I have here is I am running a MariaDB 10.5 server. So we can check this out real quickly. And I have the storage engine plugin enabled, and we can check that out by looking at information schema. So information schema plugins where plugin name like S3. And to get a nicer look, notice I have S3, it is active. The plugin maturity is still alpha, so there might be bugs. However, it is still very much usable. So let's see how we can use it. Before we put a table into S3, first of all, let's have a look at what configuration file I'm running. So the key here is that I've set the S3 access keys as well as specified the bucket and the region. I don't need to specify the host name because by default it is going to be using Amazon. And I have my data set up in Amazon for now. Let's go back to the server and let's have a look at our database. So employees, we have a few tables here. It's taking a bit longer because it's doing engine discovery. We don't have any S3 tables inside, stored inside S3 yet, so nothing's been discovered. However, the biggest table here is salaries. So show create table salaries. We see it's still running InnoDB at this point. And what this table stores is what salary a current employee via the employee number has had from a specific date to another specific date. And we want to put this table into S3. And we can do this by just doing alter table salaries engine equals S3. Now this salaries table takes a while to upload to S3. So whilst it's uploading, let's talk a bit about the database. So I got this database from Giuseppe Macchia's GitHub repository. You feel free to try it out. It's a very good test case for prototyping because it's not a very small database, but it's not a very big one either. So it's good enough to try out different things. And here I have my S3 management console. Let's see if the table has finished uploading. So let's have a look in the terminal. And yep, we see that it's finished uploading in 24 seconds. Let's refresh our S3 interface. So I'm going to do a refresh. So loading. We see we have our database name here as a folder. Inside it we have salaries, which is the table we just dropped into S3. And then we have the FRM, we have the ARIA first block, and then we have data and index folders. If we look at data, here are our data blocks, each with the block size of 4 megabytes. And the final one is just not full enough yet. And likewise, we have for the index blocks, we have a bunch of index blocks. So far, so good. Now let's try and use this table like we would normally. So back to the terminal. Let's figure out what the average salary is. Actually, no, let's get the minimum salary first. And this is the first time I'm running a query. So the first time I'm running it, it has to go all the way to S3 and back. So it's getting all the data, putting it inside the page cache, and then it's computing my minimum salary. So we got it. We see it takes around 14 seconds. But now, what if I want to get also the maximum salary for employees? I'm just going to do a max. And behold, it only took 0.7 seconds to get me the result. So that this time it didn't even touch the network because we had all we needed inside the buffer pool. Of course, it did have to check the network slightly, so that's why we have a little bit of delay compared to a local table. But it's still much faster. We can also do complex operations with this table. Now, what if we want to get the average salary for each employee? Well, we can do the average salary from salaries, and we can group by employee number. But I want the average of these numbers because this is going to be the average salary that each employee had. So I want to do an average from the result here, and I'm going to turn this one into a derived table like so. So what I'm doing here, I'm computing the average salary per employee, and then I'm taking the average out of all of these. And let's see how long this takes. 2.8 seconds. So we did have to do more computation, but we still didn't go all the way to network like we did here, where it took 14 seconds. So this is what makes the S3 storage engine good. It optimizes network traffic. And if we run it again, roughly same performance, which means that everything we had was in the buffer cache. All right, the final thing I want to do is let's see if we can insert data into this table. So first of all, show create table salaries. And I'm going to try to run an insert into salaries values. Let's pick a random number, 5. The salary is going to be 30,000. The date is going to be, let's say, 2020 10 10, and due date is going to be 2020 10 11. And notice that the table is marked as read-only. So you cannot add data inside salaries once you've moved it to S3. You'd have to move it back to InnoDB or some other table, other operational table engine, and only then can you add values to S3. All in all, the S3 search engine is still relatively easy to use. Just make sure you get your credentials right, and you should have no problems afterwards. All right, I think this showcases the power of S3 in a few simple steps. Let's go back to the final slides. All right, now you've seen how S3 can be used. I need to point out some limitations before we wrap up. So notice that because of the configuration system, there's only one S3 key per server, per MariaDB server. That means that you can't access multiple S3 providers from one MariaDB. There are plans to eliminate this limitation by storing the keys inside MySQL servers. That's probably for another development. Now, replicas on their own should make sure to not access S3 tables while the alter table command is running. Now, the reason for this is that there is no atomic transaction within S3, which means that trying to access tables whilst they're being uploaded to the cloud, you'd end up with some very strange results. Luckily, once the alter command is done, the replicas will be able to find the tables thanks to table discovery. And I did mention that S3 supports partitions. It does support partitions, but there are limitations. Operations like rebuild, truncate, or reorganize are not supported in S3. That is a debate if we should try to lift those limitations, but do let us know. And as I've mentioned, the minimum time for the first select is dependent on the S3 block size. So if that is a problem, you can try to reduce the block size. But keep in mind that we've already tuned S3 for optimum performance according to S3 specs. So reducing block size can lead to faster queries, but it can reduce throughput overall. So make your choices according to your infrastructure. That's it. Thanks so much for listening, and I will be ready to answer any questions you might have. Thanks.
Great job, Vincenzo Ciorbaru, joining live from downstairs in Grankulla, Finland. So,
everyone.
Yeah, I'd like to get the basics straight first. So S3, if you look it up, it says it's a Amazon simple storage service. But from your perspective or the perspective of MariaDB, it's a format, or rather a protocol with which one can access data. Is that right?
Yes, so S3 is a way to get your data into the cloud, or not necessarily into the cloud, but to a server that speaks the S3 protocol.
And if I wish to, I can create such a server on my own local host.
Yes, there are implementations of S3. You can take one and use it as your own. And it's
so. But the basic question here is why? Okay, I can see why on the cloud, but is it just because of the cloud? You're constantly stressing that this doesn't have to be on the cloud. Well, why would I use it if it were not for the cloud?
Well, it's a very popular format, and you have lots of tools that can speak S3. We even had a talk from yesterday about TileDB, and TileDB can work with S3. So it's a very good, let's say, data exchange format for very large amounts of data.
Format or protocol?
Protocol.
So let's say I'm then using it on localhost. Doesn't it have, if I go through an extra protocol that is understandable across the web and comparing that to the storage engine API, which is very, very internal to the server, isn't there a large performance penalty?
There is a performance overhead, especially when you go to a faraway server that's not necessarily on your own network, but somewhere in the cloud. But the way we did it with S3 is that you get the data once, and then it's in the buffer cache. So follow-up queries are going to be much faster. And I even showed that during the presentation.
So the use case here for S3 is it archival or archival primarily, but also other things? So what's the use case?
So the use case is you have data that you don't want to access all the time, but you still want to be able to access it relatively quickly, like millisecond access. It's not, you're not going to do trading on it, but it's something that you want to have available. So,
and it's read only, not read and write, or it's sort of write once, I suppose.
Well, the S3 protocol lets you write stuff all the time. The way MariaDB S3 storage engine works is once you put the data into S3, the table becomes read-only, so you cannot add more data. If you want to add more data, you have to move it back, and then you write it as part of an DB storage engine or ARIA, and then you put it back into S3. And there was a question on Zulip about partitions. So you can do the same just with individual partitions.
Yeah, that was going to be my question. How do you compare S3 to partitions?
Sorry, can you repeat?
How do you compare S3 to partitions as a way to partition data?
Well,
I mean, do you use, is there a use case where you could equally well use partitioning and S3?
Well, you can use partitioning with S3, but partitioning splits the data logically, whilst S3 puts it somewhere else.
Yeah, so but I suppose I can use S3 in such a way that I write continuously the next month's data and it's somehow concatenated with the previous month's data. If I use it for archival, usual archival method is to use to archive it by time, isn't it?
So you'd have to move it every month individually, if I get your question right.
Yeah. So you were talking now about partitioning. What about replication? Does it work with replication?
So replication works with S3. Like I've said in my talk, there are different setups. You can have one S3 provider for each server, or the same S3 provider for both servers, or all of the replicas. If you're using the same provider for all replicas, there are a few gotchas, so you need to be careful. The storage engine is still in alpha. It's progressing. We had some problems. Soon it's going to be gamma. But the thing to keep in mind is if a slave is lagging behind such that it didn't even see when the initial table was created, when the master is going to execute the moving of data to S3, because this slave has S3 discovery enabled, it will suddenly see that S3 table, and when it meets the create table statement from before, it's going to say, okay, this table already exists. I give up. This is not right.
It doesn't give up.
Okay.
Do you get extra comments by the creator of the S3 engine there in the background?
Yes, the creator of the S3 engine says the slave does not fully give up, but it's not something you want to encounter. So you need to be careful.
Okay, so I'm now excited to test this, and how should I test it as easily as possible? Should I buy some service off the cloud? Should I test it on my local host? How do I test this to get going?
I think getting the Amazon free tier is the fastest way. There's just a couple of clicks to get your account going, and then you get the security keys, create the bucket. I didn't go in my tutorial through all these steps, but it's not really hard. So I would suggest Amazon S3 for immediate get going. We're going to have some additions into MariaDB so you can test it locally. They're not there yet, but we're going to have them very soon in the next release.
So what else do I need to know about this? I mean, you now provided in your presentation good tips on how to get going. And you also said, hey, it's still not yet production level. When will it be production level?
Well, there are customers already using it in production from what I've heard. I guess we expect the community to give us more feedback if they're happy with how stable the storage engine is. From what I've heard, so far it's going well, but it's we decide when we make it stable based on the number of bugs we encounter for the storage engine. And
the stability of the engine is a separate issue from the stability of its mother release. So it yes. can become stable within 10.5, although 10.5 already is stable, but you say that S3 will be separately declared stable.
Yes, that is true. Yeah.
So we should look forward to one particular 10.5 release, and in the release note of that 10.5 release, it says S3 is now a production level.
Yes, that is true. And that's the nice part about storage engines. We can you can get them as soon as they're ready.
You can get the storage engines as soon as they're ready. So anything else I need to know if I test using your, if I get a test account, if I test it according to your script, and if I follow the announcements, that's all I need to do in order to get going with S3 for archival purposes, right?
Yes, MariaDB is also configured with sane defaults, so it should work pretty well out of the box. There are a few switches that I talk about during my talk. You probably don't ever have to touch, especially the block sizes. We've optimized them for what we're supposed to be Amazon's S3's best performing setting. But have a look at the documentation. We've documented everything about S3 there. And if you find anything that is not necessarily 100% correct, make sure to let us know.
And how do I let you know?
So you can either ping us on Zulip, preferably create a Jira issue if you think something is really wrong. Or the nice part about the documentation is that you can edit it yourself. So if you see something wrong there, you can just go and change it yourself.
And that's the knowledge base, I suppose.
Yes. Or you can even put a comment on the knowledge base. That also works.
Great. Any concluding words on S3 by you or the creator of S3?
So we actually have Monty here. Let's see if he has a few final words.
Hi, I don't know if you can see me. I know you can see me.
Yes, we can.
Yeah. So excellent present. So you got almost everything right. You missed one part about the primary use of S3 especially for the customer for which I created it. It was cheaper storage. On S3 is about 1/3 cost, at least for that customer, of the storage, and they had wanted to store terabytes of data that doesn't touch. Then S3 is the perfect solution. And for big customers with really, really big data, the only parameter they had to change is greatly increase the buffer that is unique for S3. Mm-hmm. So that's
great concluding words. So thank you both, Vincenzo and Monty. Now we know about also the reason to use S3 in the form of cheap storage. Thank you both.
Okay, bye.
The next presenter is from MariaDB Corporation, Richard Bensley, SQL mode equals ludicrous.
Hello everybody, my name is Rich Bensley and I work for MariaDB. I'm actually a software developer. I'm working on the monitoring team for SkySQL, our new cloud platform. But I've been invited to talk about my little talk that I've entitled SQL mode equals ludicrous. I've got about half an hour with you all just to cover a couple of scenarios of how I've used MariaDB in production environments in probably the most nonsensical ways possible, or at least how I've used some of the more interesting underlying features that I've previously found as a DBA to really help me out in production environments, not just in production has failed or something has gone wrong, but also how I've kind of used a few little things in system design, which I've had to like design, create, maintain, which has actually helped our environment. So I hope you enjoy it, and we're going to have some fun now. I'm gonna kick off with my first example using my favorite tool, the connecting to some MariaDB. I was a very early adopter of MariaDB 10 when it came out, and the Connect engine was one of my absolute favorites. I was working in a mixed database environment, so I jumped onto the ODBC connector very quickly to start querying other databases, not just MariaDB, from afar. I started using SQL from a database to query other databases, and I'd use it for reporting, materials used, data warehousing, ETL, ELT, all sorts. The Connect engine documentation is vast, and it supports more than one table type, not just MariaDB, not just ODBC, but all kinds of table types you can start using. And one stood out to me in particular, which is the ini table type, which also happens to be very similar to the server config file format. I thought this could be quite interesting. How can I use this? The ini table type itself is what's called an outward table. So that means when you create the table definition inside MariaDB using the Connect engine, you have to define the table name. And I did actually have a use case for this. If I just get back to my terminal, there we go. I've got Linux, MariaDB 5, 10.5. Not 5, that'd be very, very old. 10.5 running on Linux. I've got a little custom environment here set up in a way that kind of resembles some of the production environments that I encountered before, and it'll kind of take me through these scenarios. So I had this scenario where MariaDB was new to us, MariaDB 10 was new to us, and so was Linux. We're still mostly on Unix at the time. Still, after 2010, there's still plenty of Unix shops out there. And whilst the sysadmins and DevOps trying to figure out what the DBAs should do now and where the database should live, they just gave us a directory and said, you own this, you run everything as this user, and you've got some network mounts. I said, that's fine. We can just customize everything like that. In this case, we had a /mount DB kind of looking thing, and I just kept everything in one place. I could demonstrate that inside the server config, quite simple. I'm just foreseeing the socket connection for some clients in case they need it, because the default Unix socket authentication is fantastic, but I do just have to tell it it's not a default location, as I have customized it to be inside this directory. My Linux user is Vagrant, as I'm using Vagrant in VirtualBox to run this environment. So I'm running the database as this user on this system, not using the typical MySQL Servers account. So in theory, the DBA owns this environment, the files, the data directory, everything involved. And I've got just about everything I need here for the examples I'm going to be talking about today, including the Connect engine. So in that scenario as well, like you can see, I've got plugin load HA Connect, so it will load on startup. And if I just go to the server now, show engines, I've got the Connect engine listed there. There we go. That's fantastic. So I had an environment where I could edit a lot of the server configs. well, we could edit a lot within directories, but we actually packaged this stuff and we had to move it away. So we didn't always have SSH access to a box. We just package the database up with everything we need in SQL, baseline schemas. We could get it up and online from far away. Then we could connect in, perhaps set replication properties if we needed any, and whatever else we need to customize. So we didn't always have file system access. This is very important. We own these data directories, we own these databases, but we didn't always have file system access. Here, enter the Connect engine any table type. So we normally have, I think most people have probably seen this in their environments. They've got a schema or a database called DBA. In there is all your DBA tricks. And I've just got one table in here today called CNF. I'm also going to show you how I made that with a show create table, CNF, XG. Here we go. So I've got quite a simple table definition, and this actually matches the config file format that I showed you previously. That the database that MariaDB is running, and it owns that file. It's got permissions for that file, so it's using the same user. And it's an outward table, so I've got a file name defined. The engine is connect, and of course my table type is ini. So let's have a look at what this table actually looks like. Let's select star from CNF. It's not a huge table. There we go. There's that ini file. There's that server config as a table. Let's update it. Actually, I've got a copy paster over here. I'll just grab this, run that. Oh, and I included the end of line as well. So it ran it for me. That's great. Just to go over what I did, I updated the table and I set the variable value for the log output. For those that do or don't know, the log output changes where the slow query log and the general log goes. So it defaults to file, and I did say file inside the config. But you can also set the variable value to be table, and they appear inside the system schema. So I was very specific. So with variable value, with the variable name equals log output, and the section equals MySQL D. So it's quite handy that you can see my client section is up there. I said I had to specify the socket for my clients. And previously the log output was set to file, and I just updated it to table. Let's select star from CNF. Let's have a quick look. Ooh, it worked. I just updated the server config from the SQL prompt, potentially remotely. This is extremely dangerous, but it's a lot of fun and could be quite useful in some scenarios. And I definitely found it useful where they kind of set a database up for me. They want me to connect in and test things, but things aren't quite right. If I wanted to get something changed, it might take an hour, it might take a day, might have to wait to a change management window before I can actually make that change. Some things like this are a little innocuous. Of course, if you have a change management process, I'd stick to the change management process. But it was a nice little addition, and for various other table types like JSON or CSV, it was nice to have another method to connect in, edit and read files, particularly as a DBA, particularly in restricted environments. So that was quite fun. I was going to set that back. I was going to update that back to a file. I don't want any surprises at the moment. I was going to shut down the instance as well and maybe restart that and make sure it comes back. Do not want a dying instance during a presentation. That would be terrible. Show schemas. Are we there? Show process list. We're up and running. Select log output back to file. That's fine. Okay, so that was quite fun. And that in the same place, again, working with restricted access and having to go through jump hosts and things to gain access to production instances, we had a production instance which failed. And I like to call this little scenario the backup battle royale. So we had a failing instance, and everyone was looking at it. I myself had a remote SQL shell logged in, similar to the very dangerous Connect engine session I had open there. So I could actually poke around the database to see what was going on. There was minimal database activity, which was good, but the rest of the system was having lots of problems. and this system was going down. The sysadmins told us this system is going to go down, and if it doesn't, we're going to take it down. You need to put your stuff elsewhere. So, well, okay, we could do that, but the backups were from this morning, and they were already too old. The rest of the business was adamant we needed up-to-date data. So, okay, well, we can't get the bin logs. When they tear that system down, the binary logs are going to go for whatever reason. I was the last user left alive. I had my SQL session, but we also had one extra thing, which was the backup. Where we put the backups was a network mount, and the database could write to it. And I whipped out my favorite tool, Outfiles. I'm sure people have used Outfiles on and off over the years. It's by far one of my favorites. It's so simple. Along the vein of Connect Engine, I can just interact with the disk as well as remote things. And I can put files, I can just select data and put it on a disk. The default format is tab separated, so I'm going to use the TSV as my extension when I start working with things in a moment. And I've always found this super useful, not just in some odd backup restore scenarios like this, but also just in, lots of people have probably used it for ETL, ELT, for loading in and out of column store in particular, or another system, or just doing an archive backup, export into CSV, TSV, upload to a bucket like S3. However, in this scenario, I was trying to get up-to-date data from a failing system. I've got a database in here called Jam, which is a fictional jam factory where you can order jam from. And I've got some tables. Let's have a look at some tables. There we go. Let's select start from T_jam orders. Oh, well, it's 10,000 rows. I was going to do a count. There we go. Count 10,000. Don't want to see every single row. That'd be terrible. Good thing there wasn't a billion rows. Good thing this wasn't column store. That'd have been many more rows. I'm just going to create, for this example, I'm just going to create and load a table locally from disk using the in-file, out-file interface. So I'm going to select everything from the jam orders table and put it into another table. So in my actual scenario, these were remote databases. So what I'd export from one database and put it somewhere else. So we can get your database up and running somewhere else. Give me 20, 30 minutes and I'll get it done. It wasn't a huge database, but it's still important data. So I'm just going to create a new table like that table, and I'm going to call this new table New Table. Next, I'm going to select star from jam.t_jam orders into outfile. This is where the magic happens, and I'm going to specify a path of where I'm just going to write to temp. Everyone can write to temp. That's very handy. I'll call it jam orders dump.tsv. There we go. And I've exported 10,000 rows. Let's have a quick look at that on disk. WC-L temp jam orders dump.tsv 10,000 rows. So if I just tail the last 10 lines, you'll see that this is just a, so this is a row per line inside the file. And you see it's tab separated. That's the default format. You can specify more options, as you can see in the documentation. Well worth reading. You can specify the delimiters and what it's terminated by. Particularly handy if you've got perhaps some funky characters going on inside your database tables. But we don't for this scenario. Pretty simple. Date times integers. Nice and easy. I'm just going to go back to the jam database. I'm just going to select count star from new table. Nothing in there, that's fine. Now I'm going to load that table using the exported data. Load data in file, and it was /temp/jam orders dump.tsv into table jam.new table. Genius new. Load data in file into table. There we go. I'm just going to select from that table again. Select count star from new table. There we go. Show create. New table. there we go, just the regular InnoDB table, and we've exported the data to disk and loaded it from disk. So in my scenario, that was a network mount, and that was a lifesaver. We kept all the schemas inside version control, and I always thought if that wasn't there, my last-ditch effort would have been to clear my terminal, did a show create for everything, every store procedure function, every table, and put that somewhere else, then just do the load data. Thankfully, we did have the schemas and all the database objects inside version control, so I could quickly get that up to date, restore the backup, then just load the difference. For a couple of tables, I just dumped and loaded everything. For some, I loaded the difference, and that was a lifesaver. That made a big difference. I'm just going to drop that table now. Drop table, new table. I'll get back to where I need to be for the next little mission. Oh, just one caveat for in-file out-file. The only caveat which you might encounter when using this is so that file already exists, the out file I created. So if I select star from jam orders into that same file, the file already exists. That's the only caveat with the in-file out-file interface. If you're creating files, you do need to make sure that what you created doesn't exist before you do it again. So it's a shame you can't overwrite it. I guess it's kind of a security feature. And in better practices, I'd script this and I'd append a timestamp or something to the end of the file name. So it's a little bit more descriptive other than just this. But for an example, it's fine. Now I can run it and it's fine. Okay, let's go remove that file again. All right, let's clear screen and go on to the next example. Casual conversation one morning with a colleague. Somewhere, someplace, sometime. They were developing a new system, and MariaDB was now the new tool of choice for everyone, which is good. Did our jobs as DBAs. We canvassed development globally, and we got them convinced, and they were all very happy, and they'd already seen some of these kind of other things we were doing, so everything was working very well. Until the conversation came up, we've got something new, but if it gets big, how do we scale it? I said, well, don't worry about it for now. I said, let's just get binary logging enabled, and then when you're ready, we'll come do a bit more consultancy with you, and just set the bin log format to row. That's all we're kind of looking for, and just make sure the expiry is longer than the restore time. We said, well, what does that mean? So you've got an option to set the binary log expiry. So if it takes a day to restore your database, you need at least 2 days worth of binary logs. So if that restore doesn't happen, you're going to need to, if you've got another server downstream or upstream that's serving requests, and they're kind of running out of time, you need to make sure your backups and your binary logs are all in sync together. So you back up and restore to a certain point, then you might use your binary logs to do a point-in-time recovery to restore up until it's absolutely necessary. For some people, just a daily backup and restore is fine. But for a lot of customers, the scenario is a bit like that in-file, out-file scenario. Bin logs weren't available. We couldn't use a backup. It was too old. Or the backup was up to a point. So I essentially did a point and store recovery with TSV files, just plain text files. And it did kind of work. In a normal scenario, you'd use binary logs. It's a much more robust scenario, robust solution. As I say, take a lot of this with a grain of salt, but I had a lot of fun in production with MariaDB, and we solved a lot of neat problems. So anyway, I don't hear from this team for a little while, and suddenly they call up and say that the customer's using this instance. Okay, how can we help? Well, we need to dump and restore it to another database, but we don't have any backups or anything, and in fact, we kind of lost access to this instance. It broke and they need to restore it. That's essentially, it broke and we need help. But they didn't have any backups. However, they didn't actually set a binary log expiration. I said, because they didn't have any backups, they didn't have something to set it to. They said, well, we'll just keep it forever. I said, that's even better. That's fantastic. Don't worry about the backups. We'll get you up and running on a new box, and we'll apply our DBA standard to it. So there's monitoring and backups and point-in-time recovery and alerts, and we'll just restore the entire database using the binary logs. They thought that was magic. I'm going to quickly whip through this example. I'm going to use my jam database. again. I'm just going to show you there's nothing up my sleeve. I've got some different queries just to make sure I've got what I need. So if I select count a sum from the orders table, there we go, a sum of just about 1 million orders. And now I'm going to just delete everything from these tables. Just do a quick sum again. Okay, I'm just going to look at my existing binary logs. Now I'm just going to wipe out these binary logs. I'm just going to reload this database for an example. So if I do a quick select star again, so these tables are now empty, and it's a fresh database, if you like. I've got no more binary logs. If I show binary logs again, we're back to nothing. Okay, so I'm going to emulate the scenario that we are in just by using a little Python script I put together to populate the Jam database. So I'm just going to load that with data. So in theory, they started a new instance, they started loading data, they were creating tables, creating schemas and objects and all these kind of things. And while they didn't have a backup, they did have the entire binary log history. So in my case, this is only going to be inside one file. We started at 325 bytes on binlog 00001. If we just go have a quick look at the database and show binary logs, we'll see that the position counter has now moved on because we have loaded data. Now, just to have some fun, I'm going to, again, I'm just going to flush logs to move me along one log. So now we should have 2 binary logs. There we go. So now everything I do new will be recorded inside this next log. Easy peasy. And in this new log, I'm going to delete everything again. Oops, let's use Jam. And let's just delete everything again. So if I run my quantifier, there we go, aggregate function. We're back to 0. We're back to no rows. But that's okay, because I know there's one binary log there with all the data inside it. So I'm just going to go to db/data. And I am going to use the binary log command to replay the binary log against the instance. I'm just going to copy paste. I'll talk through it rather than copy pasting it. Of course, everyone noticed the new binary names are available. So instead of using MySQL binlog, I'm using MariaDB binlog. The binlog I want is 001. It's the first one. I'm only going to replay one set of database events from the Jam database into the instance, into the database, Jam. I'm just going to let that process. Perhaps I can see what's going on inside my show process list. There we go. So that's going to go through. But, oh, we're done. It was too quick. Too quick. Okay. -A, Jam. Let's go back to the database. So we had no orders before. Let's do a quick quantity on there. There we go. Fantastic. Who doesn't love binary logs? Managed to restore, dump and restore the entire database using binary logs. Very handy. Right. Hope you enjoyed that one. I'm going to cover one more scenario before I leave you all. I think most developers, DBAs, have come across this scenario before where the first thing, I've heard the story so many times, you join as a new DBA, you don't know the circumstances of you joining or the previous team or people leaving, but you've got like a database, or perhaps you've just been hired for a particular set of databases they've got problems with, and the first thing you do is lock out every single developer. Well, I did need to do this, but I didn't need to be so. I didn't need such a sort of blanket ban of all developers. What I had to actually do was lock them out of different regions, and for reasons I can't disclose, the servers in each region would be rolled over. So the master or the primary would change to each region as the world turned and the sun rose for another day and somewhere else. The new primary would move. But it also meant if developers were doing overtime in their region beyond 5-6 p.m., they could stay inside their own region, but they could not log into the new region. And we did that on purpose so they wouldn't fiddle with the current primary. So to fix this, I came up with a solution which I found in the documentation years ago. I'd seen this around init connect and init file. Init file is a server variable you can put in there, pointed towards a file full of statements, and that's SQL that can run during the server startup. Init connect covers SQL which is executed when any user connects. This is terrifying, and I use this in production to control user access, and I'll show you what I mean. Some of you may have seen inside my config file before, db-my.cnf. I've got a little line up here, init connect call auth check user account. So the connect SQL for me is a store procedure which is run. Let's go and have a look at that. So I've got a database called auth, and this is where I stored everything related to this region lockout mechanism. I just do show create procedure check user. I think it should be called check user access. There we go. I've just three variables. Just who is the current user connecting. An integer just for allowed, 1 or 0. 1 is allowed, 0 is not. The process ID, which is the user's current process ID. And you'll see in these, I just set the current user to be the current user from the user function. And I select allowed from a table where username equals current user into the allowed variable. And then I just grab the connection ID into vProcess ID. And if allowed is 0, then this select statement shouldn't actually render anywhere at all, but kill process ID. Just there for just to be a bit more clear. And I just kill the user's process ID if allowed equals 0. So let's select star from users. So everything except my jam user, root user, test user, vagrant. I've got one user here, test user, who's a bit of a troublemaker. Is not allowed to log into this particular region. I used a non-replicated table to maintain these tables in each region, and it worked well. So if I try and log in as this user to this database, it's going to read from this table using the store procedure, and it won't let me in. MariaDB -u is test user. The password is trouble. Okay, I'm in. May look like I'm in, but I'm not in. Do a quick show schemas, for example. Connection aborted. That's it. Init connect command failed. We're done. We're done. No access. Okay. Well, let's flip that on its head. Let's set allowed for the auth user. There we go. Select star from users again. There we go. So all users are now allowed. And let's try connecting again with our test user. We'll do a show schemas. Now we're in. Now we can use MySQL and select star from user because we are a troublemaker. So that was a very simple mechanism. Do I recommend it? No. It takes a lot to maintain that kind of scenario, but if you're comfortable with this kind of like change management and testing, always test, then you'll probably find it a very useful feature. And you could do all kinds of things. The init file I've used quite a lot in container scenarios. So a new server comes up in a container and I just want it to run some extra SQL. Perhaps have a container that's kind of more ready to go, rather than having to load a container as an afterthought. I can have a Docker file or something which actually loads a database on startup. It's probably one of the most dangerous but more interesting variables I've come across, or features I've come across. I hope you have some fun. I hope you kind of come away from this thinking, I'm not doing any of this in production ever. That's good. If you come away from this thinking, I'm going to do some of this in production, that's also good. I highly recommend experimenting with the Connect engine, what you can and can't get in and out. The in-file, out-file interface has been an absolute lifesaver for me. Just get data out, put it somewhere else, bring new data in, script it, automate it. Just remember, you can't overwrite the files. The init file has been a lot of fun for me, and of course, become familiar with replaying bin logs. You can do a lot of magical things, and in that particular scenario, I just restored one database from the binary logs all the way from scratch, and it worked great, and they were really happy. Thank you for listening to me, and I hope you enjoy the rest of the Server Fest.
Thank you, Richard Bensley, joining us now live from Norwich, England. Hi, Richard.
Hi, Kai. How are you?
Doing fine, and I'm noted that you got scored highly for having a fun and productive presentation up on Zulip. So that's great. And good to you're working for the MariaDB Corporation, so I suppose you don't get all that exposed to the community, do you?
Oh, actually, quite the opposite, Kai. I mean, I originally got involved with my school years ago, 15 years ago, thanks to user groups. And of course, as MariaDB came along, I moved into those. And in fact, on the corporate side, you might find in your city or town or wherever you are in the world, you might find that the corporate side, we might actually run your user group. Generally, that just involves all the lovely salespeople and things coming along, putting us in a big room full of beer and pizza and letting us talk about databases all night. So yeah, you might find that we're still very much around, and it's how a lot of us got started in the community.
Well, last time I went to London to a meetup, it was Federico Razzoli hosting it.
It was indeed. Unfortunately, he has recently moved to Edinburgh. Louisa, on our corporate team, currently runs our London group. We had a really good time under Federico's leadership and companionship. You were missed greatly, and he's got a talk later on today, also
yes,
covering more of Connect Engine. I hope to see him again soon.
So good to hear that London is continuing then. So going to your talk, it was fun, but it was also a bit of, I saw a bit of complexity there, and I'm worried if you start using all kinds of nice little semi-ludicrous features there, isn't it going to be a maintenance nightmare?
Oh yes, absolutely. You can introduce a mountain of complexity into any relational database management system. I always encourage people to read the fine manual. There is a wealth of information inside there, and everything I found that I demoed and talked about today was due to me just reading the manual and finding out what's going on. Change management and communicating change is so important. If any of our customers have had experience with the support or DBA teams, you'll know that 90% of what they do is communication. You have to set your goals, make sure everyone understands, demo features and talk about, clearly show what you're doing to other people. Some of them might get involved, some might not, but any good company, whether it's one person or 100 people or 1,000 people, 100,000 people should have a good change management system, especially around databases.
Mm-hmm. Good advice. So one of the common themes out of many of the presentations here at the MariaDB Server Fest is migration, being migration from MySQL to MariaDB or from Oracle to MariaDB or anything. So what's your take on migration?
I've actually done a lot of migration to MariaDB. Of course, I did the first hop, MySQL to MariaDB. But I also did lots of other hops. I did Sybase to MariaDB, Oracle to MariaDB. I did a Microsoft SQL server migration to MariaDB. And I jumped on board with MariaDB from 10 alpha onwards. And the two big ones for me were multi-source replication and the Connect Engine. And I actually used the Connect Engine in most scenarios, particularly when you've got these kind of older, larger legacy database systems that did become very difficult to work with. They were good back in the day, but now they've just become so awkward and obtuse to work with. One great example I had was using the Connect Engine as an authentication layer onto an old system. So our new system in MariaDB, we had a nice change management process, nice and slick, ticketed, We discussed everything every few weeks. And using the ODBC connector, we could connect to the old legacy systems. This meant that no changes were going to the legacy system, and nobody had to learn the legacy system. And we didn't have to teach anyone the legacy system. We just had a MariaDB engine looking at the old stuff until we turned it off. And we also used it for data migrations. That was good as well, just occasionally slurping data from old to new or new to old if we have to keep something in sync over ODBC. And of course, the JDBC feature is there as well now, which probably opens up even more possibilities to connect to different things and help in your migration process.
And speaking of Connect, there's a talk about that later today, isn't there?
Yeah, from Federico. I highly recommend to go see that. I'm definitely going to be watching that. I love the Connect engine. I've got a lot done with it.
So I promised to take you by surprise with a strange question. So what's the most ludicrous feature that you still recommend to be used?
If anyone's read a website online called The Codeless Code, I still think triggers are one of the most ludicrous feature. And there's a little anecdote on there about the Elephant Foot Clan, and I won't spoil it for everyone, but if anyone looks at the Codeless Code and the Elephant Foot Clan, which is the name for the database administrators, and their thoughts on triggers, and sometimes triggers can still be a real surprise, much like the init connect example I went over today. Hidden SQL or uncommunicated or undocumented SQL can sometimes be your worst enemy. But the most ludicrous feature,
are you saying that triggers are always ludicrous, that you should avoid them, and because they are so badly communicated, they are always surprising and hence no good? Is it sort of a considered evil, like go-to statements from your standpoint?
Yeah. I think that one of the most ludicrous things is often the expression, back when I was doing corporate migrations, large migrations, especially from things like Sybase, who've got their old replication server, which is very good, but it's totally closed. And I just showed people like, what is the bin log? What's in the bin log and how we can get events out? And they couldn't believe it. We can see everything that's changed and we can apply it somewhere else. Yeah, the look on their face was ludicrous when they saw how easy it was to just see every change that happened on every server. Even just pick those bin logs up, put them somewhere else and play them. And to some other systems, that's just impossible.
So that's a very positive, ludicrous feature.
Yeah, they just look at you and they shake their heads. I can't believe we could do that. It's so simple. So simple.
So speaking also of migrations, we had a chat today with Sveta Smirnova about migrating from MySQL. And the key takeaway there seemed to be do it up until MySQL 5.7. Then you will have fewer tiers. Is that your opinion as well?
Yes and no. I think it depends on your data model. I recently helped a friend get off MySQL 8. I think he just, him and his team were just a little fed up with how much change was coming their way, and it was kind of put into the user space rather than into optional. Because a lot of the new stuff we're releasing in MariaDB is something you have to turn on, or you have to go to specifically to get it. So there's lots of new things like column store being integrated is fantastic, but you have to go get it. They were using the JSON data types, and we still store it as long text, which is just so simple. So that was just those few extra humps that were coming up there. They'd already kind of adjusted tooling to have some slightly different syntax when producing some SQL commands. We've kept it all the same. So we've introduced, I dare say, far more extra features of complexity, some really good stuff, but you have to go get it. You have to go turn it on. And I think that's good that we kind of just hide it. There's still plenty of people who are just installing the LAMP stack and they just want to continue as normal. That's how I started on the LAMP stack back in 2003, 2005. And I know that I can just kind of turn on MariaDB and just kind of get on with it. And isn't that what people want?
I think so. So final question. We have less than a minute left. So you're sort of giving consolation to people weeping with MySQL 8, and you're saying it's not over yet. You can migrate off MySQL 8 without tiers. Is that true?
I think so. Just pay attention to your schema and your data model. I'm more of a Python guy, so I would kind of sit in that kind of agnostic sort of area for tooling, just to kind of pull in, pull out, and push somewhere else. And again, I could use the Connect engine just to hop over quite easily. So that, I mean, the Connect engine would just make it so easy anyway. And of course, you can just jump through the replication hoops if you want and do the switch over like that. It all still works.
Excellent. Thank you. Really great presentation, Richard Bensley. Thank you.
Thank you for having me. Enjoy the Serverfest, everybody.
And now we will have an optimizer trace walkthrough by Sergey Petrunya of MariaDB Corporation.
My name is Sergey Petrunya, and this is the optimizer trace walkthrough. Today we'll cover everything about the optimizer trace. So, optimizer trace, it's actually not a new feature. The initial prototype existed before MariaDB existed. It was initially released in MySQL 5.6, and the first release in MariaDB was 10.4 last year. After that we have added more tracing, got some experience of using it, so I think now it would be a good time to look at what optimizer trace and how we can use it. So before we discuss the specifics, let's discuss the goals. The goal of the optimizer trace is to show in details about what goes on in the optimizer. Typically the workflow goes like this. We get the SQL statement, it is optimized, then one can see the query plan if explained, then it is executed, and analyze for statements feature can be used to get information about that. But the optimization process has been fairly opaque, and now optimizer trace is used to provide details about what goes on here. And there is a lot. There are query writes, values, for example, view merging. There is very close analysis, search for query plan, finally query plan refinement. So if you have details about what goes on there, it allows you to answer questions. The most typical question is like why certain query plan is not chosen. If you have added an index and it's not being used without optimizer trace, it can be very hard to answer the question about why is this index not used. The second very common use case is why are query plans different across database instances. This is a fairly common question where somebody is upgrading from one database version to the other, or is just setting up another instance, and it has of course slightly different statistics because statistics depends on the data layout, or there are some minor DDL changes. It's like a column has now different collation. It was nullable and now it's not null, or vice versa. And these changes seem irrelevant, but one cannot tell with 100% certainty. And without optimizer trace, one had to just manually inspect all of the parts of the environment and try to guess why the query plans are different. While with the trace, you can just get trace on the old instance, trace on the new instance, and then see what the difference is. And this is much more efficient. Finally, the trace makes it easy to ask for help or report an issue to the development team. Because if having an optimizer issue and query optimization issue while uploading, your whole data set is not always possible. It can be too large, or it can contain some sensitive data. Typically, you can provide explain or table definitions, but these are not always sufficient. While the trace is of reasonable size, it is also a text document, so you can view it and remove any sensitive information from it, and then submit it asking for help, or even if you think it's a bug and optimizer, reporting it to the development team. So let's look at how one uses the optimizer trace. How does one get the optimizer trace? This is fairly easy. You just set this optimizer trace to 1, which enables saving the traces. Then you run your query. And after that, you do select star from information schema optimizer trace, and one of the columns you get is the trace, which is a really long document with the trace. The traces are stored in memory. You can use only the trace for your session and only one last trace stored. So you need to do select star from optimizer trace immediately after your query. A query can be select or it's typically better to use explain and pretty much any statement that can have a query plan. So optimizer trace contents, it is a huge JSON document. Basic idea is that it's a log of all actions done by the optimizer. Now I would like to say all actions and that you can see everything that optimizer did to your query, but unfortunately this isn't the case. The optimizer does a lot of things and not everything is traced yet. But I think we have a good subset of all actions, so all of important or typically like relevant actions are already printed, but don't expect to be it to be 100% description of what is your query. So why is it JSON? Well, JSON has two properties. First, it's human readable. It's easy to extend, so we can add more tracing as we go. The second is the machine readable. By that I mean that you can use JSON processing function to extract part of the trace. The most important ones are JSON extract, which gets the JSON document as the first argument, and then you can give it a JSON path expression to what you are interested in. And the output of JSON extract is JSON document, which we can pass to JSON detailed, which will print the JSON. So this way you can get a piece of optimizer trace, and optimizer trace is typically quite large. So it's quite useful to be able to get a small subset of it, and you don't need to resort to some crazy regress with grep. In case somebody are not familiar or don't have a clear idea what JSON is, here is one slide about JSON. JSON is a very simple simple language. Basically everything in JSON is value. A value is string in quotes, number, true, false, null. It can also be an object or an array. So array is input in square brackets, and it is a comma separated list of values. Now values do not have to be of the same type. There is no data types, so you can start an array with string, then continue with number, then add a nested array, an object, and so forth. Members of the object is similar to array, but in the object the members are named. Here there's the first object with name, and then again the value, which can be anything, and so on. Typically the names of different members in object do not overlap, and this is the case for the trace. Okay, so let's look at what is trace contents and how to interpret. Before we do that, some generic background information on query processing and SQL databases. It starts with an SQL statement, then there is a process called parsing, after which there is a parse tree, which is basically what comes into your mind when you look at the query yourself. Then there is a process called name resolution, which finds for each reference to table or view, which finds which table in the database it is. So what is the column names, what are the column data types. So if you have column 1 equals column 2, which data type would be used for perform the comparison, and so forth. So this parse tree with resolved names, there is no established name for it. Let's call it parsed query. Then there is query optimization, which comes up with a plan to execute the query. You get the query plan as a result, and then you execute. So optimizer trace is primarily targeted at query optimization, but it covers a bit of name resolution because some optimizations, some rewrites were traditionally done in MySQL and MariaDB early there. They're not large, but still you will see some name resolution parts. And for the same reason, it covers a bit of execution, although it's mostly in MySQL version of optimizer trace, not in MariaDB. But still, what you can see in the trace, you will see for name resolution, you will see join preparation member, which lists things which are basically done at name resolution phase. And one of the things that is not done is that just first it prints the query. And then I think there is attempts to merge view, and some other initial rewrites can be found there. And you can also see there is a select ID equals 1, so this is done for the top level select. Then join optimization. This is the biggest element typically, and there are a lot of things here. And finally, there is join execution element, which is generated when it is executed. As we see here, that this is all for select ID equals 1. This is because each select is optimized separately. Well, there are exceptions to that. The select can be merged to its parent select, it can be converted to semi-join, and so forth. And then for each select, the optimization phase is shown in the diagram. Although there is some exceptions, but the general workflow is that for each select, we first do rewrites and transformations. Then we collect table information and table statistics. This is like preparing for the game. Then there is a main game, join order choice. This is like the hardest choices the optimizer has to make. After the game is done, there is some fix-ups and plan refinement where we fix all the details, and this is, in the end, we get the query plan. So in the trace, this looks like this: join optimization, select ID, then there's a steps, which is an array of objects, and there are different objects denoting different things. As you see, there is always an unnamed objects because objects can't have names. Then there is a name and either object or array. So the important ones are ref optimizer key uses. This is generating ref access. Rows estimation, then again, this is also an array that for each table there is, we collect table information by estimating number of matching rows. The main game, the join optimizer choices in considered execution plans. And as a result, you get this best join order. And then there are some other fix-ups or plan refinement steps, depending on what is in your query. So let's look at these elements. Start with ref optimizer key uses. Ref optimizer, let's try a query. Select star from T1, T2, where T1 key column equals T2 key column. This will give us an explain. It has put T2 table first, then there is table T1, and it uses index lookup, it uses key column, and it uses ref access. So a question one can ask, could this use the other join order instead from T1 to T2? Here, T1.keyColumn is an integer, and T2.keyColumn is a varchar of 100 with UTF-8 general CI. If you look at the optimizer trace, we will see ref optimizer key uses. It is an array that has only one element, T1 key call, and the value for it is T2 call. And note that there is no other vice versa. So we can make lookups one way. Interesting, let's compare that with the other way. What if both columns were varchars? Let's, instead of table T1, use T3 and write the same query. And here we see that lookup is possible in two directions. There are two entries. Here there was, well, if you know the optimizer well enough, you can guess that if in integer is compared to string, then they are compared as double values, and comparison of integers, which is this index is using, is compatible with that, while comparison of doubles is not compatible, because basically 0, 0, 1 is the same as 1, when you compare them as integers, but if you compare them as strings, these strings of 1 and 001 can be very far apart in different parts of the index. Well, but with the trace, you don't need to remember all of these details. You can just see that, okay, here there is a way to look up in table T1 from T2, but not other way around. This again can be looks basic and kind of obvious for these simple cases, but can get much less obvious for much more complex cases where there are complex where clauses and the optimizer makes certain inferences of them. And believe me, even for the query optimizer developers, it's not always apparent whether the optimizer was able to infer some equality or not. The second interesting part is range optimizer. Range optimizer is a part of the optimizer which looks at the where clause and infers which ranges we may scan to find matching rows. And this inference can get quite complex. The first source of complexity is multi-component keys. Then there are also inference using equalities. If call1 equals T2 and there is call1 less than 10, the optimizer will infer that call2 less than 10, well, in most cases. And the problem for all of that, explain format JSON will just show used key parts, how many key parts are used. So let's take an example. Here there is a table some events with start date and end date, and there is an index defined on start date and end date. And then there is a query, okay, I'm looking for events with start date greater than June 24 and end date less than June 28. Like I want to catch an event sometime. And the explain will show you that 2 key parts are used, but you might be surprised at a very kind of sluggish performance, or the range access is not used at all. And if you look into the trace, you will see that surprisingly the second key part is only using null. Now the discussion of that is sort of outside the scope of this talk, but basically to be short is that the optimizer is actually not aware that the end date must be greater than the start date. And if you let him know that by adding these conditions, then you will see that the range being scanned is much more narrower, and there are a lot fewer rows in it. Another example with multiple ranges. Now let's write a query where start date is one of these 3 days, and there is just one end date. We will see that actually it generated 3 ranges, each of them using 2 key parts. Well, so far it's okay, but for longer or bigger in statements, there are this cross product of taking all ranges for key part 1 and producing cross product with key part 2 can cause some undesired effect against. So sometimes it is useful to know how the optimizer was able to handle it, because it employs some aggressive techniques to reduce the number of ranges it is producing. Closely related to range optimizer is so-called loose index scan optimization. Loose index scan optimization is optimization used for group by queries. It can be quite useful. Loose index scan can be quite faster than other grouping strategies. The choice whether to use loose scan is cost-based, so it depends on the data statistics and also on the data from analyzed table. It also has quite complex applicability criteria. So let's take an example. Let's create a table T, and create a key of 3 components: KP1, KP2, KP3. And let's set 2 very similar queries. We do group by of KP1 in both cases. Then we want to find the minimum of KP2 that is for each group. And then there is a where condition, in this case on just KP2. And here it's on KP2 and KP3 also. And explain will show that this query is using loose scan while this one is not. And it's not at all clear why would that be so. until you look at the optimizer trace. And here you see that the loose index scan is used, and here it is not, and it's usable false cause key part after infixing the query. So now we see that the problem is not data statistics, the problem is not analyzed, the problem is that in loose index scan is not usable here. Good. So let's get to the next part of it, join optimizer. Join optimizer is the biggest, most important part of the query optimization probably. And it produces two objects. One of them is considered execution path, and the second one is the best join order. Let's take a look at the example. Let's get a join. This is tables from DBT3 benchmark. There are parts which are produced by manufacturer. There are suppliers, and in the warehouse you have parts that are available in the warehouse. And so we write a join with these join conditions connecting part to part soup and part soup to supplier. And then there are also where conditions on manufacturer, part manufacturer, on supplier's account balance. So we are looking at, we want to find parts from this manufacturer provided by the supplier from with negative balance, which we actually have in stock. And this is the explain. It shows the join order. Well, best join order will show us the join order as well. And considered execution plans object will contain a log of how the join optimizer has arrived at this query plan. Now it has a lot of content, so it's too much for the slides, or too much. It would be too much for the screen, so we would need to use grep. Join order is constructed in a top-down, well, that is first to last way, and there are two important member variables here. Plan prefix shows what is already constructed, and the table shows what we are trying to add. And the table always follows plan prefix, so if you just grep, if you just save the trace to the temporary file, and then we just grep for plan prefix and also ask it to print one row after the match. So this way we find that, okay, we started with empty plan prefix and edit table supplier, then we edit table part2, then we edit table part soup. And this was, then we got back to the prefix of just table supplier, and edit part soup, and edit part after that. And this is, by the way, the join order that the optimizer eventually decided the best. But it didn't stop here, it also considered two other prefixes. It didn't, notice that here it didn't consider three table prefixes or full join orders. This is because the join optimizer aggressively prunes away. It tries to not to explore join prefixes which are not promising. And here we can actually already see which join orders, which prefixes were explored and which weren't. Let's look then at how join optimization proceeded for the join order here. So first, plan prefix is empty and the table supplier is first. If we search in the trace, we will find this one. Best access path is a function in MariaDB or MySQL source code which adds a table to the prefix. What it basically does, it considers various access types and it computes how many rows it will need to enumerate, what would be the cost, and then shows whether it's chosen or not. So here it chooses range access, which would produce this many rows. Yes, and it has chosen it. This is a rows for the number of output rows for the plan so far and the cost of it. Okay, so after the supplier, we get to part soup, prefix supplier, table part soup. That shows there are two ways actually to access it, ref access and full table scan. It picked ref access. And then there is a third one. Prefix is supplier part soup, and then we are adding table part. Again, there are two ways to read the table. We pick the ref access. And well, this is a good query plan without an issue, so we don't see any issues here. But in case you're wondering, is the optimizer considering to use certain index for this join order? Is it what estimates it's using? Here for the primary key, it's kind of obvious that there will be one match. For non-unique indexes, which have some conditions are constant and some conditions are not constant, the estimate here is computed with quite complicated computations, so it's interesting to see. If there is a where condition attached, the optimizer will try to estimate its selectivity and print it here, which this success rate of it, like say, varies a lot for not just for MariaDB. For this is a hard query optimization problem, so here this is something the optimizer can get wrong. This is how it raise. Okay, so this is the third table, the table part. So we know that how many rows the optimizer expected to see, what would be the cost, join output cardinality. Let's look at why didn't it pick the other way? We saw that it went from supplier to part soup to part. How about part to part soup to supplier? We start with table part. It would use this table scan. This is how many rows it will produce. This is the cost of it. Then let's see, table part soup is added. Then there are 3 ways to read it. It picks the best of them is ref axis on table. The best of them is ref axis. But it shows that it has been pruned by cost. Yeah, so this is how you can view the details. So join optimizer takeaway. Considered execution path traces the join order choice. It can get very large, so you have to use grep for plan prefix. Best join order will show the final prefix. By the way, hardcore JSON path users might want to, instead of grep, use searches like JSON extract and then use a filter. Unfortunately, one can't do this because MariaDB's JSON path implementation doesn't support filter. And neither does MySQL's, by the way. So you'll have to use grep and get a good text editor to navigate this very large document. So things we've covered so far, we've covered ref axis, rows, part of rows estimation, join optimizer. Well, there is a lot more in the optimizer trace. There are rewrites, various rewrites, transformations like view, CT merging into exist subquery rewrites, min max transformation. Then at collect table statistics, there is it reads data from histograms and tries to estimate selectivity. It searches for constant tables. Some tables are marked as constant. It shows the trace shows that. Table elimination optimization eliminates some tables, and it shows that. Then there is a conditioned filtering optimization, which we will see what filters are applicable for which tables. Unfortunately, this is all outside of the scope of this talk, but I hope you're getting a general idea about what kind of content is one can find in the trace and how to make use of it. Now let's look at the optimizer trace in MySQL. Now I don't want to have some kind of a match about which one is better, but I'm a big believer that we should, if there is something related or something that we could draw ideas from, we should look at it and discuss which of the implementations is better and how we could benefit. So optimizer trace in MySQL is similar to MariaDB in both user interface and the trace structure and the elements you find in the trace. There are, of course, differences. First is that the optimizers are fairly different, so there are different things printed. Also, there are a slightly different set of things being traced. So while the traces will resemble each other, I don't think just running diff might be hard. And then the tracing module in MySQL has extra features. So let's review them and see if there is anything we could learn from MySQL's implementation. The So the extras in MySQL are, the first one is that it can capture multiple traces for nested statements. If a statement invokes another statement, which can be done with a stored procedure when statement uses MySQL will be MariaDB will only save the trace for the top level statement, while in MySQL it will actually save the traces for substatements as well. This is controlled with optimizer trace of set and limit, so you can set it to save first or last n traces produced inside the statement. But the issue here is that basically there is no other support for troubleshooting nested statement. For example, you can't get explain output for this substatement. You can't get the statement time, how much time the statement has executed. Well, in some ways in some cases you can infer the statement time and even number of rows examined from performance schema tables, but this only works if your stored procedure is very simple and doesn't have any complex logic. Because if it does, it doesn't show you the statement text, so it will be really hard to figure out which statement it has in mind. So my takeaway is that I don't think this is useful in this current shape. If you have an optimizer problem inside stored procedure, the practical way would be to take away that statement out of stored procedure and troubleshoot it separately. The second extra feature in MySQL, one can omit parts of the trace. They have optimizer trace features variable, which is a set of flags: greedy search on off, range optimizer on off. These you probably recognize. Dynamic range on off, repeated subselect. So you can switch these off and then the trace will not be saved for those. Well, my answer to that why would you want to turn them? It's not an issue. The issue is not with the trace sizes as such. The issue is that we want to look at only particular parts of the trace, and typical workflow would be to use JSON extract to get the part of you need, rather than using flags to chop off the parts that you don't need. I agree that the flags would be useful for some global settings, like let's print cost values or don't print cost values if you don't care about cost values, which apply to all elements in the trace everywhere. In other words, I don't consider this. This is something we could add, but I don't think it's very important or very needed. Yet another extra is MySQL. In MySQL, one can control the way JSON output is formatted. The first thing that you can set one line flag to on in the optimizer trace variable itself, and in that case you will get trace in one line, which will probably make it take less space, but again, I personally never saw any need for it. The other one is that you can set, there is a variable called young markers in JSON. If you set it to true or on, you will have these young markers, so steps. When the array ends, you will have this comment indicating that this is steps ended, and so forth. Well, this improves readability somewhat, so somebody might find this useful. My issue with this is that JSON actually doesn't allow comments. So if you set this on, the output is not a valid JSON anymore. You can't pass it to JSON extract, for example. And maybe this should not belong to some global variable, which suddenly makes JSON something non-JSON, but rather a function which prints it. It would also add something to make it more readable. Yet another extra is that tracing in MySQL covers some parts of the query execution. Most notable user is file sort. For example, if you want to know whether file sort is using priority queue optimization, this is not shown and explained. You can only get it into if you enable the trace and run the select, not explained, but select itself. This also shows like a C memory available and other details. And well, my guess is that MySQL had to put it somewhere. They couldn't put it in explain for technical reasons, so and they didn't have explain analyze back then, so they had it save it in the trace. This is actually not a very good idea, because if the file sort is done in subquery, this will produce loads of repetitive JSON, and that's why they needed to disable it here in repeated subselect to avoid producing really large JSON documents. Well, in MariaDB, this kind of information is shown in analyzed format JSON output, which is the command specifically targeted at collecting runtime statistics. So we don't have and don't think we should have this in the optimizer trace. Analyzed format JSON shows roughly the same information. Okay, so that's for extras in MySQL. What's extra in MariaDB? You may ask. Well, in one word, just like I would say, more polish. We were trying hard to eat our own dog food and use trace for performance troubleshooting we do. So things that we did, we made printout of conditions more readable. Here's how condition looks in MySQL, and here's how it looks. The same condition looks in MariaDB. This may not look like a big thing, but this amount of ridiculous overquoting makes conditions really hard to read, especially when the query is large and conditions are long. Well, we saw that data constants are printed as hex, not dates. We fixed that. The important thing did other similar smaller fixes. The important thing that MySQL actually prints incorrect for range analysis for multiple key parts. We had a similar problem. We made the similar mistake in MariaDB, but we had caught it and fixed it before we released. Here is a bug in MySQL which shows that when I reported it to them, they didn't seem to care. So conclusions. Optimizer trace is available in MariaDB. It shows details about query optimization. You can analyze it yourself, or you can save it and submit traces when discussing or reporting the optimizer issues you encountered. MySQL has a similar feature that has some extras compared to MariaDB, but they don't seem to be important. Our future plans mostly is about printing more useful information in the trace. We want to we don't want to print everything there to flood it with content. It's already quite large, but we want to use our experience to find what would be useful and add printouts for that. So submit us, if you encounter optimizer issues, submit them to us together with traces, please. So that's it. Thanks for your attention.
Thank you, Sergei Petrunya, live from St. Petersburg. And welcome back.
Glad to be here.
Very good. Yeah. So I'm trying to keep a straight head here, not having it explode with all the traces. And one thing I was thinking about was, what do I actually trace? Should I trace the explain, or should I trace not just the explain, but also the select? I understand that the beginning of a select is equal to explain, but are there situations where I should also look at the trace select itself?
Yeah, you're right. In 99% of the cases, one can see the problem is in the optimizer itself. So one can just use to trace the explain statement and see where the issue is. But sometimes there is there are certain, let's say, leftover cases where explain and select take slightly different execution path, or it is a prepared statement which may take yet another different execution path. In that case, there will be value in tracing the select as well. But this should be exceedingly rare.
And if it's rare, my follow-up question is there overhead? But if it's so rare, it's probably not even meaningful to ask the question if there's overhead.
Well, I think there is overhead. It will be noticeable overhead because we're collecting the trace, we're dumping the conditions on many occasions, so there will be noticeable overhead. So we were thinking about whether it's feasible to have it just on always and providing the trace on demand, but decided against it because it has visible overhead.
It has visible overhead. Okay, I get it. So then I have these optimizer switch flags where I try to hint at what I would like the optimizer to decide. So how does this relate to the trace? Can I sort of see whether the optimizer took my kind hint or not?
Well, I don't, it's not directly visible. I mean, you can't look at the trace and see, okay, this is the point where we'll look at the optimizer, look at the value of the switch flag, and this flag was on, and this is why, because we were doing that. Unfortunately, this is not visible. Well, and the names also, the names in the trace are do not exactly match the names you will find in the documentation. But we have like an ongoing effort where we put examples of the trace into the documentation of optimizer features. So I guess very soon, in some cases already, you can just Google for things you see in the trace, and you will find knowledge base page describing the optimization. But yeah, but it still requires some kind of manual mental effort. It's not automatic. And
not everything can be automated here in life. Okay, so some of my coder friends are really big fans of yet another markup language, YAML, and they would say, I love to have a YAML output because it's so much more readable for me. What would you say to these coder friends of mine?
Well, YAML, I think I would share the opinion that YAML can be more readable. It typically is. Well, we picked JSON because there was already like processing. JSON was already in the roadmap, even way back when the optimizer trace was initially designed. And that turned out to be the right choice. There are now JSON processing function in both MariaDB and MySQL. There is no YAML processing function. What I think we could do is that if we make a function which converts JSON to YAML, I think the conversion should be fairly straightforward. So that way you would get the JSON output, you can then process it, extract the needed part of it, and then get it as YAML.
Okay, so you picked sort of out of laziness reasons JSON because it was already there, but now it makes sense to me. And you say that theoretically, if we really wished, you could do the conversion of JSON to YAML already from the MariaDB side.
Yeah, well, this also very isolated task. It would be a nice code contribution from somebody because it should be fairly easy to integrate. Doesn't have a lot of dependencies.
That's a great hint. So that's really a great hint. Now, I said at the outset that this is a conference for users of MariaDB, meaning those who are developers only in the sense that they develop applications, but not in the sense that they develop MariaDB server itself. But you are very right that that's an isolated feature that is a good way to get into how to contribute code to MariaDB server. So if some of you developers out there who are considering perhaps coming with contributions, this would be a great one. It's isolated and it's probably a pull request that can be reviewed fairly easily. So thanks, Sergey, for that suggestion. I have a fourth question. You sort of already hinted at the answer, but I'm thinking, would it be possible to have the trace enabled always and then save the traces of the poorly performing queries? At least for the poorly performing queries, I think the overhead of the trace shouldn't be that big. You have a very short answering time here. Your maximum latency here is 50 seconds. So that's the amount of time you have to reply to this one.
Yeah, you're right that when we're starting to optimize the query, we don't know beforehand whether it will be good or bad. So we can't, enabling directly would probably not be what most people would want. One thing that possible would be if there was some kind of a plugin, which if this is a select and we saw it performing poorly, we could immediately feed the query back again to the server with the trace on, and then we get.
Right.
Or we could get an explain and feed it. That would work even for update and other statements. And save that.
Yeah, that's a good idea. So if anybody has a good specification exactly for how this would work as a DBA, please write that into a Jira entry. But hey, you have shown that an optimizer trace talk can be absolutely fun and great and good to learn from. So thank you a lot, Sergei Petrunia.
Thank you too. Glad to be here.
Our next presenter comes from Codership Galera. It is Seppo Jaakola, who will be talking about MariaDB Galera cluster.
Welcome to MariaDB Server Fest 2020 and a presentation about MariaDB Galera cluster. My name is Seppo Jaakola. I'm a CEO and developer of MariaDB in Codership. I have a quite long track record of clustering solutions, already 15 years and over. Codership itself is a small technology company focusing in research and development, mostly around replication solutions for open source databases. Galera cluster is our product. We have started to work on that in 2008. We do business through support and consulting, and we are partner of MariaDB, and we are member of MariaDB support team for Galera related topics. Agenda of this presentation is just a very general overview of Galera replication, Galera clustering in MariaDB. There will be another presentation about Galera new features you can find in Maria 10.5 and 10.6. That presentation is also in a MariaDB Server Fest happening later on. But this is quite a general overview, just basic concepts of Galera clustering. I'm looking at the configuration of Galera cluster, how you can turn your MariaDB server to work as a Galera cluster, synchronous multi-master cluster for MariaDB. An overview of the features of what you can gain with such cluster solution, and then a few words about releases and release cycles of the Galera releases. So let's go ahead. This is a standalone MariaDB server you can get from the MariaDB distributions. So you have a clients connecting to just one MariaDB server. If this is a MariaDB 10.1 or later, you already have all the Galera software installed in your installation, so you can just by configuration turn it to operate as a node in a Galera cluster. Galera is a plugin, replication plugin, and in a configuration you need to tell that where the plugin resides. You have it in your installation somewhere on your disk. Documentation should tell where it resides. And in a configuration variable VSREP provider, you give address to this plugin library implementation. And with that, when you start your server with such a configuration, you have a single node MariaDB Galera cluster, just one node in a cluster. That's not yet a very functional cluster, so you need more members. You should start a secondary node telling it to use a Galera plugin, and also you must tell that the address of the other node in a cluster. The address is given with a configuration variable VSREP cluster address, and it's practically just the IP address of the other member in a cluster. In principle, all nodes that you configure for your cluster should have DBA Server cluster address specified, and it's a good idea to give them the full list of all potential members that your node might want to join to form up a cluster. So if you have 3 nodes, you should in your VSREP cluster address list all these 3 IP addresses. This VSREP cluster address variable is used only for the handshaking of the part of the protocol when the nodes join to the cluster. After that, the VSREP cluster address variable is not used at all. And the third configuration variable here is VSREP SST method. It tells the method how a new node joining to the cluster can get the copy of the database, so that it would have the same data content as the rest of the cluster has. Here in this example the method is rsync, so the joining node will just get an rsynced copy of the data directory. So all the files that are present in the first node will be just copied over the internet to the joining node. And with this configuration, the cluster will handshake with the joining node and then send the fresh copy of the database through rsyncing to the joining node. And when this copying is complete, the node will be an active member in the cluster. All transactions happening in both of these nodes, actually, they will be synchronously replicated between each other. However, 2 nodes is not yet a very functional cluster. You should have 3 or more. So you just need to make another installation of the same MariaDB server, configure the plugin and the cluster addresses correctly, and then join the node. And then you have a functional 3-node cluster. This is the minimum recommended size for the cluster, just for the sake of these nodes or the cluster to decide that if there are communication problems between the nodes, then the cluster must find out if there are 2 nodes who can communicate with each other, then that part of the node will be the majority, and the 3rd node will be kicked out for a while until he gets a better connectivity with the rest of the team. 3 node is the minimum number to make a meaningful voting in error situations. Usually the clusters that are deployed, they are 3, 4, 5. These are maybe the most used cluster sizes. People are usually using Galera cluster for data safety reasons. The more nodes you have in a cluster, the more copies or backups of your data you have actually in place. Every node in a cluster is a full backup of each other because of the synchronous replication that the cluster is carrying out. All writes in the cluster, they will be replicated immediately to the cluster. If you write to the middle node, the transaction will be replicated, and the transaction will be committed only in the middle node. In this example, it will be replicated to the 2 other nodes, but not necessarily committed yet before the client gets the OK status back from his commit. So we know that the commit is really complete in one node, and it may or may not be complete in other nodes, but every node has the transaction, has received and acknowledged the transaction. And also these nodes, they will, when later on, commit the same transaction. That much guarantee for synchronicity Galera cluster provides. All nodes can be used for reading, so you can safely read from any of these nodes. There are nothing preventing that, of course, and the reads are very close to each other, so the cluster progress is very even. It doesn't really matter where you are reading from. You will get the same results in practice. In a nutshell, Galera replication is a generic plugin for any database server. When we started to implement the Galera clustering, we first defined definition of API between any database server and a replication plugin. And this project there's a separate project for this. We call it Write Set Replication API project, or VSREP for short. These clusters that I implemented with Galera, they replicate write sets, which is practically the change set of happening in a transaction, and this change set is then replicated over the replication layer and then applied and made persistent in every other node in the cluster. When a database server provides this API, then it can load Galera plugin, and with that there is one node of a cluster, and having more of these nodes will build up a database cluster. With MariaDB having a MariaDB 10.1 or later installation, you just make a configuration through vsrep_variables, and then you can start playing with the cluster itself. Here is the full list of configuration variables available for Galera clustering. This is listing from MariaDB 10.4, a big number, very small text, but let's not go through this list in more detail. In practice you only need just a handful of variables for tuning. Usually it's about telling the provider and the cluster address and the SSD method. That usually is enough for a configuration. There are also status variables just to see that how the cluster is doing, and monitoring tools use these status variables. In Maria 10.4 the number of status variables for VSREP is 66. Three most used ones are VSREP ready for the cluster readiness of accepting transactions, cluster status, and cluster size. Usually monitoring solutions pull these variables to see that the overall status of the cluster. Then there are a big number of other status variables to see that how transactions are doing in a cluster, or all other aspects of the cluster healthiness. Besides of these variables, configuration variables and status variables, there are also free tables for cluster information. You can find these in a MySQL schema, VSREP cluster, VSREP cluster members, and VSREP streaming log table. The cluster table is just the definition of the cluster, the name of the cluster. VSREP cluster members, it has more information. It lists all the active nodes or members of this cluster, their names, addresses, IP addresses, and UUIDs for these nodes. So if the cluster size is 3 nodes, you should see 3 lines in this cluster members table as well. And finally, streaming log table. It's about a new feature that we added in Galera 4, which incarnated in MariaDB 10.4 release for the first time. Streaming replication is a method for replicating very big transactions or very long-term transactions as well. Galera 3 and earlier installations had a problem that if the transaction size grow over a certain limit, it could cause problems or big delays for the cluster, just because of the size of the transaction was too much for the replication system to handle. With streaming replication that we implemented for Galera 4 installations, we are splitting the big transaction to small parts, which we execute in every node at the same time in the cluster. So the transaction is kind of processing in small pieces in every node in the cluster. And the status of and state of this transaction execution is stored and maintained in this VSREP streaming log table. It can be, we use it, we as a Galera developers, we use it for guaranteeing recovery for such long-term transactions in case of any cluster problems, node hangs or node crashes or reboots. They can always take back the long-term transaction. But it can also be used for monitoring and just picking that what kind of long transactions you have in your system, how long they have been processing, and it could also be one method for troubleshooting if there is a ill-behaving long transaction going on in the system. The features that Galera cluster brings is first and foremost is synchronous replication. As I said, it's not fully synchronous, it's close to fully synchronous, but the commit is guaranteed only in one of the nodes in a cluster. But you can see or make your session to have we can call it a look and feel of a synchronous replication. There is a session variable VSREP sync weight which you can specify so that for example, your reads, when you read something from a node, it would wait until the slave replication queue is fully committed, so that guarantees that you will see all the earlier writes. You won't start processing your reads before all incoming writes have already committed. With that makes reads somewhat slower because you have to wait until replication queue is committed. The good news here is that the replication queue is usually very short, and that's because Galera cluster implements flow control, so that if there are pending transactions goes over a certain limit, by default it's only 16 transactions. So the queue you can queue up 16 transactions, and after that the cluster starts sending flow control stop signals so that every node will wait for the slowest member, and keeping the pace of execution in the cluster even for all of the nodes. Therefore, having the VSREP sync weight configured usually doesn't cause too much delay for reads as well. The installation for Galera cluster nodes makes those nodes to be equal in terms of reading and writing. You can always read from any of these nodes. You can write to any of these nodes. Galera cluster does not give you any, does not stop you doing that. But if you want to use Galera cluster as a master-slave topology, you should have a read-write splitting happening in upper level in load balancer or proxy, or sometimes some applications are clever enough to figure out that where to write to and where to read from. But for Galera cluster there is no restriction. You can always write to any of these nodes. Most installations are working in a master-slave model, so that the application or the load balancing layer will provide this read-write splitting and managing it. It's for simplicity reasons mostly. Also, Galera cluster can sort out conflicts, so you can write to any of these nodes, any table, any row. There can be row level conflicts, but Galera cluster will pick a winner and loser for any conflict, and the loser will just roll back the transaction and get a deadlock error as well. Galera cluster can retry a failed transaction because of such conflicts, so that the client doesn't even get the deadlock error. Cluster retries it, and if it's successful, the client will see that my transaction execution took 2 times longer than usually, but it was successful. So this kind of automation is also possible to have there for multi-master use cases. And finally, we have added quite a lot of automation for Galera clustering. So in principle, you only need to make the configuration correct for all the nodes. You specify the cluster addresses correctly, and after that, if you start a node, it will automatically join. Eventually, if the database size is big, if it's terabyte, it can take hours, but eventually it will be a member in a cluster, have a copy of the database, and then will be a member in a cluster. If a node drops out from the cluster for any reason, it will usually retry to join, and it might be that the administration doesn't even know or see the effect that node went out before it has already automatically joined back to the cluster. That could also happen. How much different this is then with respect to asynchronous replication? Practically all what was listed in the previous slide are actually the differences between Galera replication and asynchronous replication. In asynchronous replication, you can only write to master server, and then all the slave servers they are used for read-only purposes. Slave nodes, they may fall behind, so there can be slave lag, and that's because there is no flow control in asynchronous replication topologies. Master is as fast as possible. They allow us any transactions to come in, and if the slave servers cannot keep up with the pace, then they will just fall behind. If a master server needs to be replaced for some reason, then the whole topology must be reconfigured so that there is a new master. New master must be picked up, and every server must be configured to know that where the new master resides. So that's a management burden to have all that organized. If you are using Galera cluster for master server topology, you just write to some other server node in a Galera cluster, and that's it. So no failover needs because of Galera in such scenarios. How about the versions then? So we started the Galera development in 2008, quite long stretch already, like 12 years of Galera development. First versions for MariaDB came, if I remember correctly, for 5.5 and then also 10.0. But starting up to that point, there were additional Galera clustering implementations that were not part of the MariaDB software stack itself. But starting from 10.1, Galera clustering is accepted as in MariaDB mainline. So with later MariaDB releases, you get a Galera cluster, Galera replication included, and it's up to you to make the configuration to start using Galera cluster. Turn your MariaDB server to a cluster working with Galera replication. We have given Galera major version numbers starting from 1, and most recent one is now 4. These are versions that make a big impact for the overall behavior of the cluster. They also contain a jump in the VSREP API, so the replication API has changed, and the way that the Galera plugin and database server communicate has been changed. And because of these changes in this API level, then whenever there is a major Galera major version upgrade, it means that we also need to prepare a rolling upgrade path for the solution. For database users, it means that when you step, for example, the last big change was between Maria 10.3 and 10.4, and upgrading from 10.3 to 10.4 needed to happen in a certain way to make it safe. You need to have your first all your nodes in a cluster to be upgraded to the latest 10.3 version, and then node by node, just upgrading one node in a cluster to operate as a 10.4, and then the second node, and when the last node of the cluster has been upgraded, then the cluster is in the level of 10.4, and after that the internal replication in cluster starts to use the Galera 4 replication methods. You cannot downgrade after that, so your cluster is then in a Galera 4 level, and your upgrade is complete. This rolling upgrade is usually quite tedious job to do, so testing wise we have to do it, reserve quite a lot of time to do that carefully and make sure that all live systems can be safely upgraded to the new version. Because of this, we want to pack all changes for the replication API to happen not so often. So the Galera replication 4 came with Maria 10.4. Now we have a 10.5 which is using the same VSREP API level, and for Maria 10.6 we have not yet decided that what kind of features will go in there, but it may be that there's a major change in a Galera or not, but this is something to be decided actually quite soon, in a matter of 1 or 2 months. Alright, last slide here, summary of this presentation. Galera clustering itself, it's present in MariaDB releases for a very long time. Starting 10.1, it's already in every Galera MariaDB release. Reason to use it, what people are saying is that synchronous replication first and foremost, quite most often looked reason. Then the data safety, because of the fact that every node is a full backup of each other. That's also seemed quite important feature. And multi-master needs sometimes not so much that we were anticipating when we started to use the develop a Galera cluster. We were hoping to see the performance impact of writing to several nodes, but that's not something that that the applications need so much. But it's multi-master use case is good for generality, so that you could treat your cluster equally. It doesn't matter. You don't need to care where you write to, and if your application is not sensitive to conflicts, write-write conflicts and seeing deadlock errors, then this might be a good solution for such application as well. Galera works well in wide area network and cloud installations. No problems there. It's mostly because the replication itself it's not sensitive to latencies in the network connections. Galera 4 came with MariaDB 10.4, and it has 10.4 overall has significant new Galera 4 features and other MariaDB features as well. So if you want to start evaluating and experimenting with Galera, I suggest you begin with 10.4 or later, just to avoid the rolling upgrade that you would need to do if you are in 10.3 or earlier. You have a one sure rolling upgrade experience coming up quite soon. This rolling upgrade, as I said, it's supported so far follow all versions, and that's our policy that our users, they are usually running clusters which need to stay up 24/7. There is usually not much accepted downtime for the cluster, and because of that we need to make sure that whatever we release, it's possible to upgrade online in a hot system. That's all from my part, and I guess questions are coming in a separate session after this airing, and don't forget the next presentation. It's also coming from Galera cluster about 10.5 and 10.6 new features coming later. Thank you and bye-bye.
Thank you, Seppo Jaakola, joining us live from Capilla, Finland. Hi there, Seppo.
Hi, Kai. How are you? Server Fest audience.
Yes, I'm very happy that you gave the Server Fest audience an overview of the introduction to Galera. I've heard quite a number of the latest things with Galera, but sort of if you do just the diffs, where do you get the core part of it? So thanks for giving a basic intro. And looking back at this intro, I'll make it even more basic and ask you a very simple first question. What is the basic use case scenario for Galera cluster? How does it differ from replication?
Well, when we started the Galera development back in 2008, we had practically two targets there. One was to get better performance, especially for writes, and the second was high availability. And now with these 12 years that we have followed the success of Galera deployments out in the production systems, I must say that what people are really looking in Galera replication is for high availability and safe data safety. With Galera cluster, all your nodes are backups. The replication is practically synchronous. So if you can commit your transaction, you can be rest assured that your data is safe and you cannot lose a transaction. There are many applications which have this strict requirement that you cannot lose a transaction, and especially financial or gaming solutions. And for those, this is the only way to go, is synchronous replication.
Is that also why you say that you need 3 nodes or more instead of just 2 nodes?
Yes, 3 nodes is exactly for this. So with 2 nodes, well, practically you can play safe, but it will cause you downtime. So if you lose one of the nodes, when you bring it back, it needs the help of the other node to get in sync. Right. And so there is a window of downtime.
So you were describing history, ancient history 12 years ago, looking at the environment to which you connect the cluster. So is there something surrounding it? Do you have load balancing recommendations? Should I use a proxy? What's your take on that?
Well, we don't actually care about that, how people connect to the cluster. So the replication works under the database server, and the way that the connections come to the MariaDB server, it actually doesn't cause any differences for the replication. But for the sake of simplicity, I would say that the proxies like MaxScale are the best option, because with that you can get the read-write load balancing done for your application if the application cannot do that on its own.
Okay. So then you have this statement that you resolve multi-master conflicts. Well, that sounds like a patent solution, black magic. How does it happen?
Well, it's based on actually the research paper that we started to work on, and it's very well explained there in the theoretical language. But to put it in a nutshell, so every transaction will just list all the data elements that it modifies within these transactions. And we have this description of the transactions in our replication system. And in the replication system, we can take a look at incoming transactions, that what they have modified, And if there are conflicts, we choose the first comer as a winner, and the second one is the loser who must roll back. That's the thing in a nutshell.
Great answer for a nutshell. Now it'll have to be even shorter. Can you give a 30-second answer on how do I take backups from the cluster?
Every node in a cluster is already a backup. So the simplest way is just to take a node out of the cluster and then bring it back after you have saved your backup. But there are a multitude of other solutions as well.
Perfect. Great answer. Well, looking forward to see the next presentation on Galera. I think you're up next as well. So thank you, Seppo.
Yeah, thank you, Kai.
Now for a look forward, the Galera clustering in MariaDB 10.5 and beyond by Seppo Jaakola.
Welcome to MariaDB Server Fest 2020 and a Galera cluster for MariaDB presentation. My name is Seppo Jaakola. I'm a CEO of Codership and a MariaDB developer. Codership is the smallest technology company focusing in research and development for open source replication solutions. Galera cluster is our main product. We have been working with that since 2008. We do business through MySQL and MariaDB consulting and support, mostly with MariaDB Corporation. Since 2007 we have been doing continuous growth and our team is growing constantly. Here is the agenda for this presentation. This is about Galera cluster in MariaDB, the latest features of that, so it's more technical. There is another presentation in MariaDB Server Fest, which operates more like an overview on an introduction to Galera clustering. In this presentation, I first talk about Galera releases, how Galera came to be in MariaDB. Then the newest major features, practically Galera 4 in Maria 10.4, and new features we have been adding in MariaDB 10.5, and also some features that we plan to put in 10.6. The development for 10.6 has already started with our team. Galera cluster development, it started in 2008. It was first only for MySQL, but quite soon we all started to develop also versions for MariaDB. Up to 10.0 release, the Galera clustering in MariaDB was an add-on product, so you had to have a separate installation for MariaDB Galera cluster. But then since 10.1, Galera has been integrated in MariaDB mainline. So if you have a MariaDB 10.1 or later, then you also have a Galera product included. It's only a matter of configuring your MariaDB server to work as a Galera cluster. 10.2, 10.3 were just minor releases from Galera perspective. There were many major versions, of course, for MariaDB, but for Galera clustering, not that big improvements. But in 10.4 we had a Galera major upgrade. We started to use the latest Galera 4 replication there. It included also the replication API change, so the integration or migration from 10.3 to 10.4 requires more attention because of this. And 10.5 came out this summer. It's the latest from our side, and in this presentation I look mostly on the features that came in 10.4 and 10.5 and also the new features planned for 10.6. When we talk about Galera releases, we have divided major releases with just a small integer number. We started with 1, 2, 3. Now the latest one was called Galera 4. and that's in present in MariaDB 10.4 version. The replication API that we call VSREP API, it has also integer number, but it goes from 1 to 26, so there has been much more API changes than the major Galera version changes. But what matters for the end user is that whenever the replication API is changed, then the upgrade can be more challenging. It requires a rolling upgrade path, and that's what actually we had to do in our development, so that we test that carefully and provide a way to have make it possible to upgrade a full operating cluster without any downtime to the new version of Galera replication. Galera 4 releases in 10.4, it included this API change, as I said. The latest VSREP API is number 26. The biggest feature that we brought in there is streaming replication. Streaming replication was originally implemented to support big transactions or long-lasting transactions as well. Here is an animation that how streaming replication can support a long-term and a big transaction. We have a client and a free node cluster. When the client starts a big transaction, it first launches in the first node, but as soon as we detect that the transaction has a big size, we replicate it to the cluster so that every node in the cluster will also launch a matching stream replication transaction. And when the transaction processes, it provides some result sets. All these results are then replicated, so the transaction is live in all of the nodes in a cluster. So in a sense, it's a distributed transaction processing system. And when the client finally commits, all these transactions will commit in the same time. It looks quite simple from surface, but developing this and making sure that it's always safe to use that, and it's also safe when there are changes in the cluster. Let's say that the node goes down or more nodes join to the cluster while there are ongoing streaming replication transactions. The cluster does not know that when the transaction eventually will commit, so there is no guarantees that upfront that we could decide that should we wait or not for certain operations. The cluster must be able to handle all possible situations. Because of this, and to make it safe, the development cycle for streaming replication alone was very long. It was like 3, even 4 years to take it from drawing table to the final release. We were suggesting streaming replication already for MariaDB 10.3, but it didn't catch that train. Then it was delayed, and finally in 10.4 we got the streaming replication in the MariaDB releases. GTID compatibility work started for 10.4 and is now present in 10.5 release. It's a work done by Mario Caruso. The underlying problem or the challenge of GTID support is that Galera has a GTID of its own. It has 2 elements, UUID and a sequence number of the transaction, whereas MariaDB has a free element free element GTID with domain ID, node ID, and a sequence number. The plan and design for GTID support now for Maria 10.5 is to make Galera cluster to also provide similar GTIDs in the format of MariaDB for this reason, we use the same domain ID and node ID in every node in the cluster, so that the end user of MariaDB cluster would see the cluster as just one single MariaDB server with the same domain and node IDs. Galera cluster will now store and show for the end user only MariaDB format GTIDs. And Galera cluster can also operate as a slave for external MariaDB master server, and the GTID coming from the MariaDB master is also preserved in a Galera cluster, so you can find the same transaction that was committed in the MariaDB master server. You can find the same GTID also in the binlog files of a MariaDB Galera cluster. Cluster error voting is also a feature that came with the 10.5. It's work by Alexei. The idea here is that there is a new protocol for cluster nodes to agree what to do when one or several nodes in the cluster have problem in applying of incoming transaction. The problem could be suspected inconsistency or some other reason for not being able to apply the transactions. Here is an animation how it goes. We have one client sending a transaction, maybe a problematic one, and a 5-node cluster. The client finally commits the transaction. As usual, the commit is replicated to the cluster. Cluster is happy with it, so the commit gets OK status packs. Client thinks that commit was successful. Well, it was, at least in the first node. But the applying of this incoming transaction, it can happen somewhat later. And in this case, 2 of the nodes have problems in applying the transaction. So they saw that this is not possible. And now the error voting protocol kicks in. The first node seeing the problem sends a message to the error voting protocol, and then every node in the cluster starts to vote, telling that what was my success with this incoming transaction. The healthy nodes say that okay, this I had no problems, but 2 of these nodes tell that I had a problem. And when every node sees the votes coming, then the nodes that see that they are in a minority, they will just shut down. And as an end result, we have only 3 nodes in a cluster. From the end user perspective, he issued a transaction. It was good. And also the cluster is good after that. But 2 nodes went down, so the DBA should step in and take another look at why these 2 nodes failed to apply the transaction, and then fix the problem if there is some, and then rejoin these nodes back to the cluster. XA transaction support, work by Daniele and Leandro. What we mean with the XA transaction support is that we want to make it possible for Galera cluster to operate as a resource manager in an XA infrastructure. So there's a transaction coordinator somewhere else who wants to operate with several resource managers, where a Galera cluster is just one of these resource managers. So Galera cluster should be able to prepare an XA transaction, and after prepare to either roll it back or commit. If it has prepared the transaction, it also must be able to commit if the transaction coordinator wants him to commit the transaction. This XA transaction support is possible after we implemented the streaming replication. We use the streaming replication as a foundation for running XA transactions. We had this work already ready for 10.4 release, but it was not accepted there, and we moved the target to 10.5, and we almost got it there. During last springtime it looked that okay, we have a Galera XA in 10.5, but what happened there behind the scenes is that 10.5 had also some other work related to XA transaction support in the MariaDB proper side, and that work conflicted with our work for Galera replication, and we had to wait to get the MariaDB XA implementation first in. And finally it came out that there was not enough time to get our work done and well tested. So we left in a situation where we had to just pull back the proposed Galera XA support for 10.5 and delayed it to be scheduled for 10.6. So it's a practically 1 year delay for getting XA support for Galera cluster in the MariaDB. I have two features, non-blocking DDL, to discuss also. It's quite long-term work that we did. My font is yellow here because this is not in MariaDB community server, it's only in MariaDB Enterprise Server Edition. For that reason, I'm not in this presentation going through the details. I'm just telling you that this work has been done. It probably will be later in MariaDB Community Edition as well. This is work by Teemu, and the idea with the non-blocking DDL is to execute the DDL in 3 phases, where phase 1 and 3 are blocking ones, but they are very short. We do those phases just to agree on taking a metadata log for the later coming DDL operation. And the phase 2 is the long-lasting phase where the DDL is actually rolled into the system, but the cluster is not logging that phase. There is only the metadata log protection for that operation in place. For configuration, we have one new online schema upgrade method, NBO, that can be chosen. People usually use the total order isolation, but with the MariaDB Enterprise Server it's possible to use the blocking operation as well. Another one MariaDB Enterprise only feature is black box, work done by Pekka. Black box, in a nutshell, it's a debug message storage held in ring buffer in main buffer. So when the MariaDB server is operating, it stores all kinds of debug level information in a quite small area in a ring buffer, and if the server might crash brutally, we can always go back to the black box to take a look at what happens in the last seconds when the node was still running. It helps in troubleshooting a failed cluster, or we have found out also that it's very helpful in testing, cluster testing as well. And finally, the last slides of this presentation is about MariaDB 10.6 planning. We completed our 10.5 related work in early summertime. We have this XA transaction support that was practically ready for 10.5. We continue with the testing of that and also documenting it, so we should be very well prepared for 10.6 release to have the XA support finally in. But this implementation, one of the reasons to implement XA transaction was our interest to fundamentally to implement the Sharding cluster based on Spider storage engine, and this work we can now do. The Spider cluster would operate like this. So we have the Spider cluster is the upper level cluster with 3 nodes using Spider storage engines, and then we have a cluster for each shard of the Spider engine. In this example, there is only one table, spider, which is belongs to the spider storage engine, and it has two fragments, A and B, and each of these fragments is then served in respective Galera cluster. The left-hand side shard cluster has 3 proper Galera nodes, and the purpose of this cluster is only to serve the incoming XA transactions related to changes for the fragment A of the spider engine table. The right-hand side shard cluster has 2 proper nodes and an arbitrator, so that would be the minimal deployment type of a sharding cluster. 2 proper nodes for data safety, and then the arbitrator for all kinds of voting situation if the cluster has some kind of hiccups in the communication. In real life, you obviously will have a lot more fragments or shards in your table, and a big number of servers needed to run these kind of topologies. But this is interesting work, and mostly because it's the way to the final way to the right scalability. The performance and kind of the workload in each shard cluster is quite minimal. It's only each shard cluster needs to care only about the data that's one part of the big table. So the load per shard cluster is quite minimal. The only question is for the overall throughput of this system is that how big a bottleneck the spider engine will be in the upper level spider cluster. We have started some ongoing work for 10.6 as well, so the XA and spider cluster testing will be of course part, but some other work that we do for 10.6. We started with the test system improvements that doesn't show up for the end user so much, but for development it's very important part. We are extending the test coverage and improving the tests so that they would be deterministic and not so false positive so often. It will help in the development and avoiding regressions in the future releases. 2 new features have been worked on. First one is dynamic SSL or TSL encryption. Earlier you had to either use SSL encrypted group communication or not. You needed to do that up front, but now you can dynamically switch on and off, and you can change, for example, your SSL implementation to have another implementation variant of the encryption used for the cluster. This work is code complete. It's in a testing phase at the moment. Another one is the optimization for streaming replication. The way that we implemented streaming replication for the first version was very conservative and safe, just to cover all the possible error scenarios when cluster has members dropping from the cluster and joining in, and we had to make sure that it's always possible to recover an ongoing streaming transaction. Because of this, we used quite a lot of extra resources, and that caused the actual long-term transaction to last a lot longer than it would in a for example, compared to a single node or a standalone MariaDB server operation. But with this optimization, we plan to make the transaction throughput of such large transactions much faster. This is in a research phase, and the implementation has just started based on the design that was done in a research phase. So these 3 tasks are ongoing. Then we have a list of feature requests that we have got during the 10.5 cycle and what we are hearing from MariaDB Corporation as well. The list is quite long, like 20 to 30 new features. We cannot do all that for 10.6, but during the next 1 or 2 months we will pick up the winning features that we want to put in 10.6 for the next springtime. Yes, that's about all for Galera cluster 10.5, 10.6 for MariaDB. Thank you listening and have a nice MariaDB Server Fest 2020.
Welcome back, Seppo Jaakola, and thanks for your presentation now on the new features. Joining again from Capila, Finland, aren't you?
Sure I am. Thanks, Kai.
Good. So you were talking about new features, of course, and one of them was streaming replication. How should I think about this? How should I use it? What does it mean specifically from a performance perspective?
Streaming replication was maybe the biggest challenge we have been working on for the past 3-4 years already. And the reason that we started to work on this was that we became aware of how bad effect big transactions actually have for replication system. It was not obvious because when you just look at the standalone server, you can have several connections, transactions like 1,000 connections easily. And if there's a one long-lasting transaction which is populating a lot of data, even that it's not conflicting with anybody, let's say that it has his own table that is only loading into data and takes time and goes on. So no harm done if this is in a cluster in the first node in a cluster. But when you replicate, when you are ready to commit your transaction, and in a clustering systems, we have a strict commit order requirement. So all transactions must be committed in exactly the same order in every node. Now, when this big bulk comes to the replication, it goes to all the other nodes than the first node. The first node is already, it gets rid of this long-lasting transaction. It's so no problems, but every other node must fully apply this transaction first and then commit. And while they are doing this, nobody else can commit. I have seen situations where this one big transaction could take, when one customer case I had, it was 27 minutes. And the cluster was just idling. And the only advice I could give to the DBA is that do nothing, sit on your fingers now, because you cannot help it. You just have to wait it until the cluster digests the big bulk of this transaction. For this reason, we started the work for streaming replication, and finally it came with first time with MariaDB 10.4.
So it was 10.5 and beyond. So what about the beyond part? Can you now summarize briefly the new features for 10.6, the ones that you're working on right now?
Well, not the full scope for 10.6 is not yet completed or agreed on. We work with the MariaDB Corporation to look at what the customers need. This is the first and foremost driver for our work, and then we look at the community, what they want. But we have already started the 10.6 work. The first kind of task that we took for us is to stabilizing the test system. We added a lot of more effort for the testing and stabilizing the 10.6 framework. And we also started 2 new features. Well, the first one was the XA transaction support. It was originally planned for 10.4. It missed the train. There were so many other features coming in. Then it was planned for 10.5, but it missed that train as well, largely because of there was other work for XA transaction support in MariaDB ongoing, and our work was conflicting with that, and we couldn't resolve all the conflicts. But now it's in the train for 10.6. So it's definitely coming, and it's already ready. We are testing with it, and it's just a matter of testing and documenting to get it in there. So XA transaction support will be there, and then we have an optimization for streaming replication. As I said, we can cut these big transactions, and that's the intended use case for XA transaction today, is that you only configure it to cut those very big transactions and not use it for every transaction. But in the long run, we want it to be usable for any sized transaction on a regular basis, and with that you can effectively run XA transactions in a Spider cluster, for example.
Good. So I have a final question. It's probably a yes/no question. That's about the amount of time that you have. So Spider cluster, is that for? Can you do InnoDB tables as well on that one, or what is it for?
Well, the Spider is the way to split the tables, and our intended use case is to have a hybrid solution between Spider engines and then InnoDB tables for regular use. This is
that was exactly the amount of time you had. So thank you, Steph, for very good answers and very good presentations on Galera clusters. Thank you.
Thanks. Bye-bye.
Next up, Federico Razzoli, playing with the Connect storage engine.
Hello everyone, Federico Razzoli here, and I will talk about MariaDB Connect storage engine. So who am I? I am a database consultant specialized in MariaDB and MySQL ecosystems, and I recently started this new company called Database. So let's talk about Connect. Before explaining what Connect is, let's see what a storage engine is. Well, the thing is, MariaDB knows very little or nothing actually about how to write or read a row, or write indexes, caching data, and so on. So these functions are implemented in special plugins types called storage engines. If you know nothing about storage engines, well, whenever you create a table, it is of type InnoDB, which is the default storage engine, and it is absolutely a reasonable choice because InnoDB supports all the reasonable features, and its performance are ideal for the generic use case. Still, there are reasons to use different storage engines sometimes. So, an interesting thing is that actually when MariaDB asks, okay, Mr. Storage Engine, please read this row or write this row, actually Mr. Storage Engines could do anything. MariaDB will never know or doesn't even care. So for example, Black Hole Storage Engine writes absolutely nothing. The data you insert in a black hole table simply disappears, as the name says. Sequence returns sequences of numbers. Spider is used to read and write data remotely, and it's used basically for sharding data over several servers. And CSV, for example, handles a file of type CSV on disk. So let's see Connect. If we run a simple query, we can see that Connect describes itself as a storage engine for management of external data. This means that it is conceived to read data from external data sources, understand them, and then do something with this data, as if they were regular SQL tables. So, and actually it's called Connect because it connects MariaDB to some other data in some other form. But other form can mean many things depending on the table type. So basically there are table types that read data from remote DBMSs. It could be MariaDB, but it could be also something else. There are table types that use data from files written in various formats, like CSV, but also JSON, XML, or many other formats, actually. There are special data sources. For example, in Windows, you can even see the information about available network interfaces. You can see this information as a table. And there are table types that make some kind of data transformations, and we will see at least one of them later. So we have just half an hour. We don't have centuries, so I can only talk about some specific things. We will focus on file-based tables, and then we will start playing a bit with Connect. So file tables can be of two macro types. Okay, they can be inward or outward. I'm using these terms as they are used in the documentation, even if I believe that they should actually be swapped. Okay, but anyway, basically a table is an outward table when we specify the file name clause, as in this simple example. Okay, we are creating a very simple table and we specify a file name. This means that we are going to use a file that already exists, and for this reason the file is considered somehow holy, okay, because it comes from the outside and we cannot ruin it somehow. Okay, so this affects the way alter table is performed. If we drop a column, for example, what will happen is the column will disappear from the table, but not from the underlying file itself. So what changes is if we can see that information or not, but the information is still there. If a table is inward, well, the underlying file is modified instead. So an inward table is a table based on a file, like in this example, because we are still using the table type CSV. So a CSV file will be created, but we will not use an existing CSV file. Okay? So we cannot specify a name for the file, but this is not a big problem because we can easily guess it. So the file name is the table name dot a meaningful extension, in this case CSV. If we are not sure about the name, we can run show warnings after create table, and we will see a warning which tells us the name of the file. Here I show a regexp to take the file name from the warning. It's easy because it's simply the last word. So an interesting use case for Connect is the following. Receive data in a certain format that we understand, make some changes that is easy to make in SQL. So these are two trivial examples. For example, we only specify some columns, or we specify a group by, and then we export the result of this query in some in the same format or in another format as we prefer. So how to do it? Well, in the simplest case, we create an outward table. We use create table select to basically run the select that we want to run to make some transformations on the data and save the result in a Connect table, and then copy the file elsewhere and then drop the table. Or if we want to make some more complex transformations, we can create again the outward table, run create table for the intermediate data. We can use InnoDB. Then we can add indexes. Then we can make some transformations on the intermediate data, and then we use create table select, and we can also specify well, of course, engine connect and the table type, and probably some other options to specify the format that we want to use. Like, for example, in this case, we specify that the separator character is a tab, and first line is not data, but is the names of the columns. And then, of course, we copy the file elsewhere, and we drop the table. If we have an existing table and we just want to export it in some format supported by Connect, well, this alter table is probably the most efficient way to do it. Just keep in mind that this is an inward table, and therefore we cannot specify a file name and a path. This is not a big deal, just you will need to copy the resulting file to some other place. So, enough talking, let's try to read some Apache logs. We will use a very small sample, which is basically a sample of the Apache error log for database.com. The IPs are scrambled, so you will not see any secret. So here's some lines from the file, and okay, basically some considerations. The log uses a precise machine-readable format, but it's not very regular. It's not as easy to read as CSV or JSON. Okay, so we cannot simply use table type equal CSV and expect it to work. Okay, we will have to do something slightly more complicated, because we will have to define a mapping between the data written in the file and the columns those data refers to. Well, we don't care about all the columns. So, okay, this is a line, so this is the list of information we care about, so the IP, time zone, and so on. As you can see, between the various data, there are some strings that are fixed. They are the same on all rows. So we will just have to communicate these strings to connect. So here's how we create the table. I will not explain every single line because it requires too much time. So, of course, we specify engine connect, then we specify table type FMT, which stands, I suppose, for format. We specify a file name with a path, because I think it's better for most cases. I mean, you don't want to simply put the Apache log into MariaDB data directory. It would be quite dirty and dangerous. And, of course, in the create table, we have a list of columns, and you can see that for each column, we specify field format clause. This is not MariaDB SQL. This is an option which is only understood by Connect. The most important thing to notice is these are like templates, right? Where we have %sign followed by another character. So %n is just a market. It means here the data that needs to be in this column begins, and then the next n means here the data ends. And then inside these two markers, we have %s or %d, or we can have also something else. Basically, it is the same format used by some C functions like scanf. And then before or after these markers, we can have a fixed string. Okay. So it's easy to make mistakes while doing this. So unfortunately, it's not very easy to find out what you did wrong. So the first error here is what we get if we probably don't specify a full path, or we specify maybe a wrong path to the file. And the following error message is what we get if field format is not correct for a certain column. It's not very informative, so if you get this error, you will need to work a bit to find out what was wrong. So if we select a line from this data, we can see the result, and it's mostly okay, but you can see it's not perfect. So the time column includes a beginning square bracket, the time zone column includes a final square bracket, and protocol includes a double quote. These characters shouldn't be there, but basically I tried to exclude them, and I didn't succeed. After spending some time on it, I looked at the documentation and I saw they actually had a very similar example, but they also used some sort of workaround. Okay, so it's like for some reason we cannot have a perfect table for this kind of data. So instead of wasting more time trying to get a perfect result, which I don't know if it is possible, we can do this. We can have some virtual columns which basically use some SQL expression to drop a character at the beginning of the string, like in the first example, or at the end of the string, like in the other examples. Probably it is not really necessary, so we can have some additional trailing characters, and we don't necessarily need to care about it. But if we want to have complete data, we can use this trick. So this query shows that basically this works well. Now let's do some analysis on the Apache log file. Okay, of course, as you can see, we can run at this point any SQL query. So, for example, we can group data by a certain column. But what if we want, for example, to pivot the data? MariaDB does not support syntax to get pivoted results. Okay, but we can use a special connect table type which is called pivot. So before doing it, some forward. Connect tables that transform data in some way basically establish a connection to MariaDB just like any other client, and run some queries, and then get the results, and then transform the results in some way. But in order to do that, they need to use a username and probably a password. So it is a good practice to have a MySQL user in our databases. It exists by default because it's created by MariaDB install DB tool. So in this slide, you can see the create table that we can use. We specify table type pivot, We specify the name of the base table, which is weblog in this case, and usually the table is in the same database as the new connect table, but if it is not, we can specify a database name. Then we have option list, where we put, first of all, the credentials to use to connect to MariaDB and get the data from the base table. And here you can probably see why I suggest to use MySQL user, because it uses by default the Unix socket authorization plugin, and as a consequence it doesn't require a password, because the authentication is actually done by the operating system. In this case it works because MySQL is the Linux user used to run MariaDB. So we don't need to specify a password, which is very good, because if someone inspects the table structure, well, they will see the passwords. I mean, they will see the complete option list. Okay, so the next two options are what actually define how the pivot works. And basically the pivot column is request type, and the function we're using is count, but we can actually use any other aggregate function like sum, AVG, or anything else. And you can see the result here. You can see that the values for the pivot column are, for example, get and head, and they became columns. But this result is a little bit inconvenient and almost unreadable. And to make things work, we cannot even specify select request type and then get and then head, because these special columns are created during the query execution, and if we mention them in a query, well, the query will simply fail. This happens because a pivot table type is meant for tables where we only have the column to be pivoted and aggregate data. This doesn't work usually for a log, but instead what we can do is to create a pivot table which is based on a query and not on a table. So in this slide you can see what we are doing. I will not show the whole create table again because it's a waste of time, and I will only show what's changed. Okay, the option list is shorter, and we add a source def clause, which basically contains the query to execute. And the query is very simple, is just a group by request type. Okay, so basically when we query the pivot table, each value from request type column became a new column. Okay, and the value is just the count as requested by our query. This is a very simple pivot table. We can do much more interesting things with pivot tables, but probably not in the case of a log, at least. Maybe we can, but I'm really not aware. But anyway, there are also other transformations that you can do with Connect. So you can see the other transformation here. So the occur table type basically unpivots the columns. So basically it turns columns into basically values of a single column. It is the opposite of pivot. Xcall turns string lists, for example, comma separated, into multiple rows. And table, basically, it's defined on a set of tables, and it allows to use them as a single table. So this was basically the last thing. What did we leave out? Almost everything, because the topic is huge. Connect really supports a lot of stuff, and we just played a bit with an Apache log. So we left out the other file formats like JSON, XML, HTML tables, fixed length files, which are familiar, for example, for COBOL programmers. We left out compressed tables because we could have read the Apache log in a zipped format if we wanted to. We left out the magic we can do with custom formats, so for logs in strange formats, the connections to remote DBMSs, MySQL, ODBC, JDBC, MongoDB. We left out that we can query remote REST APIs, which is not really simple because you will have to write some code for this, and it only works on Windows, but still you can do if you really need it. And we left out more stuff. So to make you not too sad for this, I'm including 2 final hints, which are, first of all, build proper indexes where possible, and then if your queries on Connect are still slow and the files you are working with are big, you can increase Connect work size cache, because it's the cache used by Connect, and if the size it is by default something like 60 mega, but if it's not enough because you are working with big files, you should probably increase it. And of course, if you have to do elaborated queries, well, also consider taking the data away from Connect and move them to some InnoDB table. Okay, so this was the last slide. So thank you everyone for attending. I hope that the talk was useful, and this is question time.
Thank you, Federico Razzoli, calling in from London. Hi there, Federico.
Hi there, it's great to be here.
Likewise. So the Connect engine, I'm trying to go back to the basics here. Migration is a common denominator of many of our talks here at the MariaDB Server Fest 2020. Is Connect primarily for migration, or only for migration, or what's the basic use case?
Well, migration is surely one of the use cases, but it's not the only one. For example, you could have a Connect table in which you regularly import data from elsewhere, maybe from some remote service or other technologies. And then you can, again, import data regularly and keep all the data in MariaDB to take advantage of the power of SQL. Or the opposite, of course, you could even export data regularly to have them in some other technology.
So this is not a read-only thing. So the Connect engine, just to emphasize the basics, you can read and write, can't you?
Yes, exactly. You can read and write. For example, if you have a table which points to a remote DBMS, you can insert data.
Can you also like create a new table in a remote place? Like, can you run DDL over it?
No, you cannot create or drop or alter existing remote tables. And I think it's correct, because otherwise it would be a bit dangerous.
So speaking of dangerous, one of the use cases here is, of course, to migrate data off proprietary databases. So is this somehow open source license magic that through the use of the Connect engine, you can automatically read proprietary databases?
It would be interesting, but no, I don't think there is any magic here. So you have to already have some running, for example, Oracle instance, which already has a license, which is valid.
Okay, so this is clearly for on top of an existing solution, and it's both for import and for export. I have a technical question here. Does it make any sense to connect to MySQL this way? Like we have the same protocol mostly and the same data types. So does it make sense to connect with MySQL?
Yes, exactly for the same reasons you said. The protocol is more or less the same. Connect is totally able to use MySQL native protocol. MariaDB and MySQL have the same data types, so you can easily connect to remote MySQL table.
Okay, so you said that the DDL doesn't work. You cannot create tables externally, but what about creating indexes for them? Is that possible, or would the original files then be somehow modified?
Yes, there is some limited support to indexes. You mentioned the case of files, and well, simply indexes are created in a separate file, so the original data file, for example, a CSV, is not modified.
Right. And what if my CSV file has malformed rows? Can I connect to a CSV file that is actually containing bad data?
Yes, you can actually configure that. You can decide how many errors you are going to tolerate before your operations simply return an error.
Cool. So looking back at the Connect engine, it was created in France by a developer called Olivier Bertrand. So Olivier Bertrand is one of the biggest contributors to the MariaDB server code base used with this Connect engine. I understand, I asked you beforehand whether you met him. You said no, but do you have any greetings to Olivier Bertrand?
Yes, absolutely. First of all, I hope to meet him at some point. At the first opportunity, and I want to tell him thanks for the great plugin you produced, and hope to get in touch sometime soon.
So what do your users, your customers say about the Connect engine?
Every time I mention Connect with a customer and I explain what Connect is and what it does, they are amazed because it actually solves concrete problems. And I don't have an explanation of why it isn't much more used than it actually is.
So you think it deserves many, many more users because the use cases are so prevalent?
Absolutely, because in modern times, companies don't use only one technology. As good as it can be, they always use a mix of technologies, especially, for example, if they have microservices, they could have different microservices using different databases. Maybe they use something else for caching, something else for data warehousing. And so it's very common to have this problem of importing or exporting data to some other type of database.
Good. So more use cases or more use of the Connect engine is something you welcome. But what about performance? Isn't it always overhead to have an extra layer, like in this case, approaching an external database using the storage engine layer? So what's the performance penalty?
Well, of course, when you connect to a remote database, there is much more network activity involved. So the performance cannot be the same as querying a local table. And also you can have problems if you try to do complex joins between tables. But in that case, you're probably not using connect in the best way.
Yeah, I would probably import stuff first before doing complex joins. But can you give some ballpark figure? Is it like 5% or 50% or 500% performance penalty for using connect for external tables?
Oh, well, it really depends on your table, but on your queries. I would say that if your queries are very slow because they are analytical queries on big data sets, well, in that case, most of the time is took by your query itself, which is executed elsewhere. Using connect is not necessarily an important overhead. It depends.
Okay, so you're saying somewhere between the 5% and 50% is the likely overhead.
Yes, it's very vague, but it depends on a lot of factors. So yes.
Yeah. So basically, the performance impact is not so high as for this to be something that you rule out. So for not just in a scenario where you do import-export on a one-time only basis, but for regular import-export, you pointed that out. And the prerequisite for that is, of course, that performance is manageable, and you say it is.
Yes, if what you do is regular import-export, you probably have a window of time during which you know that this operation is taking place, and you are prepared to wait some time. Of course, it's completely a different story if you try to run regular queries on a connect table, which connects to a remote data source. But again, that is not a correct usage of connect, in my opinion.
Right. We heard earlier here today about the use case where some authentication tables, which were not too big, were being accessed by Richard Bensley from over the Connect engine. So he's also a big fan. So hey, we're all big fans of the Connect storage engine. Great work, Federico. You have some more presentations here coming up. So talk to you again soon. And thanks, Federico.
Thank you all. It was great. And thanks again to Olivier.
So that was it for today. I hope you liked it. If you did, feel free to share it on social media, LinkedIn, Twitter, hashtag MariaDB Serverfest. And tomorrow we'll continue. I would say same time, same channel, but the channel won't be the same. There's a new YouTube link, and you'll find it on mariadb.org/fest2020. So see you tomorrow.